Pipe dream. Pirate first.
Pipe Dream Part 6. MXTM aka Pirate 1 or VJ Tsunami X. July 12, 2026. Pipe Dream. Part 6. The Visitor Experience. Chapter 1. Paddle Submarines. Every transportation system reveals the civilization that designed it. The automobile reveals a civilization that organized itself around the premise that individual speed is the primary value of movement, that getting from origin to destination as fast as possible, with as little encounter with other people's movement as possible, is what mobility means. The subway reveals a civilization that organized itself around density, that moving large numbers of people efficiently through constrained urban space is more important than the comfort or autonomy of any individual in the system. The horse-and-carriage reveals a civilization that organized its landscape around the biological constraints of an animal that must be fed, watered, rested, and stabled, that the movement of the civilization was bounded by the carrying capacity of one of its biological dependencies. The pedal submarine reveals a civilization that organized itself around the premise that the experience of movement is as important as the movement's destination, that passing through a space has value independent of arriving somewhere, that the physics of the transportation medium can be chosen for the encounter it produces rather than for the throughput it maximizes. The Crystal Tube Network's maglev propulsion system can move a pod through the freshwater zone at speeds the cenote's passage geometry permits, in silence, without physical effort from any occupant. This capability exists. The decision not to use it as the primary visitor transit mode was a design decision, the decision that the visitor who arrives in the freshwater zone's aquifer environment and passes through it at the speed that maximizes transit efficiency has experienced the transit. The visitor who pedals through it, at the speed the flywheel's steady output produces, has experienced the aquifer. The pedal submarine is the civilization's argument that the aquifer is worth experiencing, that passing through it is not incidental to arriving at the attractions it contains but is itself the primary attraction. Every engineering decision in the cycle sub's design is the physical expression of this argument, the transparent hull because the aquifer is worth seeing, the flywheel's steady output because the experience's pace should be determined by the environment scale rather than by the occupant's urgency, the soda-lime scrubbing canisters because the human body's presence in the aquifer is a metabolic event that the aquifer's closed atmosphere must manage, the wetlock's dry vacuum pocket because arrival at a destination inside the aquifer is a physical event with physical protocols, not a metaphorical crossing of a threshold. The cycle sub is not a novelty ride. It is the civilization's primary interface between human experience and the formation it inhabits. The hull. The cycle sub's hull is translucent polymer, a composite specification whose exact formulation sits at the intersection of the structural engineering requirements, impact resistance for the docking protocol's mating sequences, pressure tolerance for the freshwater zone's depth range, chemical compatibility with the cenote water's calcium bicarbonate chemistry, and the optical requirements, sufficient transparency to present the aquifer environment at the resolution the unaided human visual system can engage with at the 1 to 5 meter distances the tube transit's passage geometry produces. The hull is not PMMA, cast acrylic's brittleness under impact makes it unsuitable for the docking port's mating sequence, which involves the sub's nose cone contacting the wetlock's conical alone reception disc at the alignment velocities the electromagnetic roller decelerates to before the final approach. The hull is not polycarbonate in its standard formulation. Polycarbonate's yellowing under UV exposure is not a concern in the freshwater zone's depth-attenuated light environment, but polycarbonate's surface scratch susceptibility under the docking protocol's repeated nose cone contacts requires the anti-abrasion hard coat that adds to the hull's maintenance cycle and reduces the optical clarity at the contact zone over time. The hull material is a co-extruded laminate, polycarbonate substrate for impact resistance and structural compliance, with an aluminosilicate glass ceramic thin layer co-bonded to the exterior surface at the molecular level. Not an adhesive bond between two materials but a compositional gradient in the extrusion profile that transitions continuously from polycarbonate to glass ceramic across a depth of approximately 3 mm. The gradient transition produces a material whose mechanical behavior in the interior layers is polycarbonates, ductile, impact-absorbing, thermally compliant, and whose optical and surface properties in the exterior layers are the glass ceramics, hard, scratch-resistant, optically stable across the UV range the surface tear's light exposure produces. The hull's co-extruded gradient structure is the physical embodiment of the material's philosophy Part 2 documented, not a single material that compromises between requirements, and not two materials bonded at an interface that is the weakest point, but a compositional transition that allows each material to perform its correct function in its correct location within the same continuous structural object. The polycarbonate does what polycarbonate does where polycarbonate's properties are required. The glass ceramic does what glass ceramic does where glass ceramic's properties are required. The gradient transition is where they become each other. The interface is not a point. It is a volume. The hull's optical clarity in the gradient laminate's glass ceramic exterior layer produces a refractive index close to the cenote waters, less exact than cast PMMA's near match but closer than standard polycarbonate. At the cenote water's 1.33 refractive index, the glass ceramic exterior's approximately 1.47 refractive index produces less optical distortion of the aquifer environment than polycarbonate's 1.586. The guest looking through the cycle sub hull at the synthetic reef on the crystal tube wall exterior sees the reef at a distortion level that is perceptible under careful inspection but not perceptible during the natural visual engagement of a guest whose attention is distributed across the aquifer's full visible volume rather than concentrated on a single point at close inspection distance. The hull's geometry is not a cylinder, the obvious choice for a pressure vessel, and the choice that minimizes material cost and fabrication complexity. The hull is an elongated ellipsoid, a lens-shaped cross-section that produces lower hydrodynamic drag than a cylinder at the transit speeds the electromagnetic roller provides the pilot and passenger side-by-side seating geometry that the coordinating system's passenger experience monitoring has identified as the most effective arrangement for the shared observation experience the transparent hull's aquifer view produces, and presents the widest optical field to the passengers at the mid-hull seating position, the maximum view angle that the hull geometry's curvature allows. The side-by-side seating geometry requires explanation. The conventional submarine's tandem seating, pilot forward, passenger aft, places the passengers in a visual hierarchy where the forward occupant's head occupies the center of the aft occupant's field of view, reducing the aft occupant's optical access to the aquifer environment by the angular subtended by the forward occupant's head. In the transit experience's design hierarchy, where the aquifer environment's visual presentation is the primary design objective, any geometry that reduces any occupant's optical access to that environment is a geometry that is wrong about what the sub is for. The side-by-side geometry's cost is higher air resistance during transit. The wider cross-section the two seats side-by-side placement requires increases the hull's frontal area relative to a tandem arrangement. At the transit speeds the cycle sub operates at, the hydrodynamic drag difference between the side-by-side and tandem geometries is the electromagnetic roller propulsion system's problem, not the occupant's problem. The roller provides the propulsion. The roller's energy consumption is the operational cost of the side-by-side geometry's optical benefit. The coordinating system's energy accounting trades the propulsion cost for the optical benefit without philosophical conflict. The propulsion cost is quantifiable, the optical benefit is the design objective, the trade is favorable. The flywheel and the pace. The electromagnetic roller's standard transit speed through the crystal tube network's freshwater zone passages is the boulevard's operating speed, the speed at which the aquifer environment's biological and geological character is legible to the unaided human visual system in the transit's moving frame of reference, documented in Chapter 4 Part 3 as the foundational parameter from which the boulevard's transit mode is derived. The pedal submarine's pedaling mode is not the standard transit speed. The pedaling mode is slower. The flywheel receives mechanical input from the pedals at the cadence the occupants choose and stores it as rotational kinetic energy. The transmission converts the flywheel's rotational energy to the drive gear's engagement with the guide rail's physical teeth at a gear ratio that produces the sub's forward velocity. The gear ratio is selected to produce a forward velocity that corresponds to approximately half the boulevard's standard electromagnetic transit speed when the occupants are pedaling at a comfortable sustainable cadence, the cadence that the human physiology's aerobic threshold allows for extended periods without the anaerobic fatigue accumulation that would make the transit physically demanding rather than physically engaged. The flywheel's kinetic energy storage smooths the pedaling input. The occupant's pedaling cadence inevitably varies, moments of increased effort as interest in the aquifer view distracts from pedaling rhythm, moments of reduced effort as a formation feature demands both occupants' visual attention simultaneously, and the flywheel's rotational inertia absorbs these cadence variations, delivering the smoothed average cadence to the drive gear's engagement rather than the instantaneous cadence variation. The forward velocity is steady. The occupant's pedaling is variable. The flywheel is the buffer between the human's variable effort and the environment's need for a steady pace. The pace at which the flywheel-driven cycle sub moves through the freshwater zone is the pace at which the aquifer scale reveals itself. The freshwater zone's characteristic passage dimensions, the typical clearance between the crystal tube's exterior and the natural limestone wall in a well-proportioned intersynode passage, at the boulevard's electromagnetic transit speed, passes in the visual field at the rate that the brain's object recognition system identifies as comfortable scanning rate, fast enough to maintain interest, slow enough to resolve detail. At half the boulevard's transit speed, the scanning rate drops to the rate that produces leisurely examination, the visual pace at which the brain is not scanning but dwelling, not identifying but appreciating. Dwelling and appreciating are the cognitive modes that the visitor experience requires for the aquifer environment's biological and geological complexity to register at the resolution that makes the experience genuinely informative rather than merely spectacular. Spectacular is the amygdala's response to novelty and scale, the bolt of recognition that something large, unusual, and visually complex is present. Informative is the cortex's response to dwelling, the slower accumulation of specific observations about the large, unusual, visually complex thing that converts the bolt of recognition into actual knowledge. The cycle sub's slower pace is the pace of the cortex's experience, not the amygdala's. The pedaling's physical engagement contributes to this cognitive mode in a way that passive transport does not. The occupant who is pedaling is not a spectator in the aquifer environment. They are a participant. Their physical effort is the cause of their movement through the space, creating the proprioceptive experience of having earned the distance traversed. The aquifer environment encountered through physical effort is an aquifer environment that the occupant has navigated, not merely observed. The navigation is minor. The guide rail and the electromagnetic orientation system handle actual navigation, but the physical sensation of pedaling produces the experience of navigation regardless of whether the occupant is actually controlling the trajectory. The body pedaling. The sub moving. The aquifer revealing itself. The experience of exploration. The magnetic coupler. The cycle sub's through-hole magnetic coupler is the engineering solution to the problem that the flywheel's mechanical output must reach the external drive gear without any physical penetration of the hull's pressure boundary. A mechanical shaft through the hull would be a pressure boundary penetration, a point at which the hull's integrity depends on the seal around the shaft rather than on the hull material's continuity. Seals fail. The through-hole penetration is, in any pressure vessel operating in a water column, the most likely failure point. The magnetic coupler eliminates the penetration. The flywheel's rotational output connects to a magnet array inside the hull at the coupling position. The magnet array rotates with the flywheel. On the exterior of the hull at the coupling position, a second magnet array is mounted in the drive gear assembly, separated from the interior array by the hull material's full thickness. The two arrays' magnetic fields penetrate the hull material. The hull's polymer matrix is magnetically transparent. Magnetic fields are not blocked by non-ferromagnetic materials, and the exterior array follows the interior array's rotation through magnetic coupling. The interior array's rotation drives the exterior array's rotation through the hull wall, without any mechanical connection, without any penetration, without any seal. The coupling's torque transmission capacity, the maximum torque the magnetic coupling can transfer before the exterior array's magnetic field alignment with the interior array's field breaks down and the coupling slips, is the flywheel's maximum deliverable torque multiplied by the safety factor the coupling geometry provides. The coupling geometry specifies the magnet array's diameter, the number of pole pairs, and the separation distance through the hull to produce a coupling torque capacity that exceeds the flywheel's maximum deliverable torque by the factor that prevents coupling slip under the worst-case load condition, the maximum drag the drive gear experiences in the worst-case current event that the Cenote's hydrodynamic model specifies. The coupling slip condition is the system's primary warning that the drive gear's load has exceeded the flywheel's torque capacity, typically because the current in the passage has increased beyond the model's expected range, or because the drive gear has encountered an obstacle in the guide rail's physical teeth that is resisting the gear's forward engagement. When coupling slip occurs, the drive gear stops rotating while the interior magnet array continues rotating. The slip is audible to the occupants as a change in the flywheel's rotational frequency without corresponding change in the forward velocity. The coupling slip is the system's communication to the occupants: something has stopped the drive gear, and the pedaling effort that they are delivering to the flywheel is no longer producing forward motion. The communication is immediate, physical, and unambiguous. The occupants pedaling at normal cadence feel no change. The flywheel's rotational inertia absorbs the coupling slip's change in loading. But the forward velocity ceases, and the velocity cessation is the occupant's first indicator. The sub drifts in the current's direction rather than advancing along the guide rail. The electromagnetic roller's deactivation indicator on the instrument panel, a simple light that confirms whether the electromagnetic roller or the mechanical drive is the active propulsion mode, is the second indicator, confirming that the mechanical drive is engaged and the coupling has slipped. The occupant's response is to reduce pedaling cadence, allowing the flywheel to decelerate toward the coupling's engagement torque, which is lower than the coupling's torque capacity and lower than the peak torque the slip event exceeded. As the flywheel decelerates to the lower coupling engagement torque, the drive gear's load from the obstacle or current event either resolves, the current event passes, or the obstacle was transient and has cleared, or the coupling remains slipped, indicating that the load is sustained and above the flywheel's reduced delivery capacity. The sustained slip is the condition for the Terraform operator notification. The coordinating system's monitoring of the cycle sub's drive system status detects the sustained slip event and notifies the Terraform operator through the standard monitoring alert pathway. The coupling slip is the mechanical equivalent of the building's crazing failure signature, a deliberate, observable, early warning failure mode that communicates the system's stress state to the occupants and the monitoring system before the stress produces a consequential failure. The coupling slips instead of the hull penetrating. The slip is the warning. The penetration is what the warning prevents. The docking sequence. The wet-lock docking port, the translucent conical alone reception disc protruding from the crystal tube wall or the Cenote hub's exterior surface, is the cycle sub's arrival and departure interface. The docking sequence is a protocol with specific physical steps in specific order, not because the sequence is complex beyond the requirements of the physical situation, but because the physical situation involves equalizing atmospheric pressure between two enclosed volumes across a water-filled interface, and the order of the equalization steps determines whether the equalization proceeds correctly. The approach: the cycle sub's electromagnetic roller, reactivated from mechanical drive mode as the sub re-enters a crystal tube section with active electromagnetic infrastructure, decelerates the sub from transit speed to approach speed in the final 20 meters before the wetlock port's conical receiving surface. The sub's nose cone, shaped to the same conical geometry as the wetlock's receiving disk at the male-female contact angle, contacts the receiving disk at the approach speed's residual velocity. The contact is controlled by the electromagnetic roller's deceleration profile, which the coordinating system's dock approach management layer calculates for each docking approach from the sub's current position, velocity, and the dock's current atmospheric pressure and water level status. The seal, the high-diameter nitro-rubber ring that surrounds the receiving disk's interior circumference, inflates on nose cone contact, conforming to the nose cone's exterior surface geometry and creating the initial seal between the sub's forward pressure boundary and the dock's receiving disk. The inflation uses the dock's atmospheric pressure as the inflation medium. The rubber ring's inflation chamber is connected to the dock's atmospheric supply through a control valve that the contact sensor signal opens on nose cone seating confirmation. The ring inflates against the nose cone's exterior. The contact seals. The water evacuation: the vacuum pump in the dock's mechanical suite evacuates the water that occupies the space between the sub's forward hatch and the dock's inner hatch, the wet volume that is the transition space between the sub's internal atmosphere and the dock's internal atmosphere. The pump's evacuation rate is calibrated to the volume's dimensions, producing complete evacuation within a time period the coordinating system's docking protocol specifies. The evacuation is the reason the docking port and the sub's nose cone are both made of alone. The vacuum produces a large pressure differential across the nose cone's alone material, and alone's compressive strength under the vacuum's differential pressure provides the structural safety factor the protocol requires without adding structural mass that would increase the sub's hydrodynamic drag profile. The pressure equalization: once the wet volume is evacuated to below the water level sensor's minimum threshold, confirming that the space between the hatches is dry, the pressure equalization valve opens, equalizing the atmospheric pressure between the sub's internal atmosphere and the dock's internal atmosphere. The equalization is confirmed by the pressure sensors on both sides of the inner hatch reporting equal pressure within the tolerance the protocol specifies. The inner hatch opens on pressure equalization confirmation. The arrival: the cycle sub-occupants unbuckle from the seating restraints that the approach protocol requires be engaged during the docking sequence, a requirement derived from the approach deceleration's occupant comfort and the docking sequence's pressure equalization's postural stability requirement, and step through the inner hatch into the dock's transition gallery. The transition gallery is the smallest enclosed space in the installation, barely large enough for two people and the equipment they carry, but it is enclosed and atmospheric, which means the occupants are no longer inside a submersible but inside a building. The building extends in all directions from this point. The transition gallery is the threshold. The cycle sub that has just docked is not immediately available for the next occupants. The wetlock seal must be maintained while the dock's transition gallery is occupied. Releasing the seal would expose the transition gallery to the cenote water through the nose cone's interface. The seal releases after the inner hatch seals behind the occupants. The transition gallery pressure confirms full equalization with the dock's interior atmosphere, and the outer hatch's seal integrity sensor confirms that the transition gallery to outer passage boundary is sealed. The sequential confirmation is the safety protocol. The seal releases only after all three confirmations. The sequence protects the transition gallery's atmospheric integrity. The experience of the wetlock docking sequence is the experience of arrival inside the aquifer. Not arrival at the aquifer. The transit through the crystal tube has been the aquifer's continuous presence through the hull. Arrival inside: the transition from the enclosed pod's atmospheric isolation to the building's atmospheric continuity, the transition from the aquifer visible through the hull to the building's atmosphere extending from the transition gallery in all directions into the cenote hub's full spatial volume. The threshold is the inner hatch opening. The building is on the other side. The Avalo system. The cycle sub's buoyancy management in normal operation is the guide rail's problem. The electromagnetic rollers coupling to the guide rail provides the downward force that counteracts the sub's positive buoyancy in the freshwater zone's water column, maintaining the sub's depth position within the crystal tube regardless of the sub's buoyancy state relative to the ambient water. The sub floats upward to the crystal tube's inner surface if the guide rail's contact is lost. The crystal tube's inner surface is not a hard contact. The maglev effect centers the pod within the crystal tube's cross-section, maintaining the millimeter clearance between the pod's exterior and the crystal tube's inner surface that the crystal specifications maintenance protocol requires. The pod floats upward. The maglev returns it to center. The Avalo system: the carbon fiber hydro tank with internal rubber bladder that allows manual neutral buoyancy trim independent of battery power. is the cycle sub's buoyancy management in abnormal operation, the battery failure scenario where neither the electromagnetic roller nor the maglev system is available to maintain the pod's depth position. The Avalo system's principle is direct. The hydro tank's rubber bladder is pre-inflated with compressed air to a specified pressure before each dive. The compressed air in the bladder occupies volume that the hydro tank's outer shell would otherwise fill with water. The bladder's compressed air volume determines the cycle sub's total buoyancy. More compressed air in the bladder means more displaced water means more buoyancy. The Avalo system's manual control allows the occupants to release compressed air from the bladder through a manual valve, allowing cenote water to enter the hydro tank as the bladder deflates, increasing the sub's mass relative to its displacement volume and reducing its buoyancy. The manual valve's control produces buoyancy trim. Reducing buoyancy below the sub's natural positive buoyancy makes the sub denser than the water column and the sub descends. Increasing buoyancy toward the sub's natural positive buoyancy allows the sub to ascend. Achieving neutral buoyancy, the specific bladder inflation level where the sub's mass exactly equals the water column's displaced mass, allows the sub to hover in the water column without either ascending or descending, without the guide rail's electromagnetic contact, without the maglev centering force, without any power-consuming active system. The neutral buoyancy achieved by the Avalo system in a battery failure scenario allows the cycle sub occupants to pedal the flywheel and drive the mechanical drive gear without fighting either positive buoyancy or negative buoyancy. The sub neither floats away from the guide rail's physical teeth nor sinks away from the guide rail's upper surface. The pedaling produces forward motion along the guide rail's physical teeth. The sub advances. The guide rail provides the navigation reference. The strontium illuminate markers provide the visual reference. The soda lime canisters provide the atmospheric management. The Avalo system provides the buoyancy management. The four emergency systems together constitute the blackout protocol survival equipment for a cycle sub in a power failure scenario. Avalo for buoyancy, flywheel and mechanical drive for propulsion, strontium illuminate markers for navigation, soda lime canisters for atmospheric management. All four are passive, none require power. All four are mechanical, none have electronic components whose failure in the power failure event that has already failed the electronic systems would further reduce capability. All four are operated by the occupants through manual controls that the training protocol prepares every passenger to use before the first transit begins. The blackout protocol's emergency training for cycle sub passengers is not an emergency procedure briefing in the airline safety demonstration sense, the passive recitation of procedures that the statistically negligible probability of the emergency makes the audience not retain. It is a practical training session. Occupants entering the cycle sub for the first time are guided through the Avalo system's manual valve operation, the flywheel's engagement sequence, the mechanical drive's clutch engagement, and the soda lime canister's indicator monitoring at the surface tier's training pool, a shallow atmospheric pressure pool where all four systems can be operated in a non-emergency context before any transit begins. The training is not offered as an option. It is the prerequisite for transit authorization. No occupant enters the transit network without completing the training session. The coordinating system's transit management layer tracks each occupant's training session completion timestamp and requires the timestamp before authorizing the cycle sub's electromagnetic roller release from the docking port. The training is the infrastructure's safety architecture applied to the human occupant. The person who is inside the infrastructure when it fails is the emergency system's operator, and the operator who has practiced operating the emergency system before the emergency is more effective than the operator who has only been briefed. What the cycle sub teaches. The cycle sub is the visitor experience's most effective educational tool not because it contains educational content but because it produces an educational experience, the direct sensory encounter with the aquifer environment at the pace, scale, and physical engagement that converts sensory data into lasting understanding. The guest who has pedaled a cycle sub through 3 kilometers of crystal tube passage, watching the reef community's succession stage change between tube sections, hearing the aquifer's acoustic background through the hull's vibration conduction, feeling the halocline zone's temperature drop through the sub's hull thermal transfer, navigating the strontium illuminate markers through a simulated blackout in the training protocol's practice run, this guest has not been informed about the cenote system. They have experienced it at the resolution their own body's sensory apparatus provides. Informed guests who have read the pre-visit orientation materials, watched the cenote overview video in the surface tier's orientation gallery, received the terraform operator's geological and biological briefing, know facts about the cenote. Experienced guests know the cenote. The difference between knowing facts and knowing is the difference between the orientation video's voiceover describing the halocline's optical dissolution effect and the guest's visual field dissolving into the halocline's gelatinous shimmer during the actual halocline transit. The voiceover produces a concept. The transit produces an experience. The experience produces understanding that no concept fully captures. The cycle sub's design is the experience's instrument. The transparent hull is the experience's visual aperture. The flywheel's steady pace is the experience's temporal scale. The pedaling's physical engagement is the experience's proprioceptive layer. The docking sequence's pressure equalization is the experience's arrival event. The strontium illuminate markers in the training run's blackout simulation are the experience's emergency comprehension. All of these are engineering decisions made for engineering reasons that together produce the educational experience as their aggregate outcome. The civilization that builds its primary visitor interface as an educational instrument that the visitor's encounter with the formation teaches the visitor something that no secondary experience of the formation's documentation can teach, is a civilization that has decided what kind of visitors it wants to produce. Not visitors who have been to the cenote and seen the attractions. Visitors who have been inside the cenote and experienced the aquifer, who know, in the specific way that physical experience produces knowledge, what it is to move through the freshwater column at the speed the flywheel produces, to feel the halocline transition through the sub's hull, to see the reef community change across the succession stages between tube sections, to dock at the wetlock and cross the threshold into the building that the aquifer contains. The visitor who has been inside the aquifer in this sense is not a tourist. The word tourist implies a consumer, someone who has purchased access to an experience that someone else produced. The cycle sub's occupant has produced part of the experience themselves. The pace of the transit is the pace their pedaling produced, the path the route the guide rail navigated, the arrival the docking sequence their cooperation with the protocol allowed. The experience is a collaboration between the occupant's physical engagement and the infrastructure that the engagement operates within. A civilization that produces collaborators, not tourists, has solved the fundamental tension between visitor access and ecological integrity. The visitor who has collaborated with the infrastructure, who has physically engaged with the pace the ecosystem requires rather than the pace the visitor prefers, who has experienced the formation through the interface the formation's conditions specified rather than through the interface the visitor's comfort preferences would have specified. This visitor has a different relationship to the formation than the tourist does. The tourist has consumed the formation. The collaborator has met it. The cycle sub is the meeting's instrument. Coordination across the fleet. The cycle sub fleet, the full population of cycle subs operating in the freshwater zone's crystal tube network at any moment, is managed by the coordinating system's transit management layer as a distributed vehicle system in a constrained network. Constrained because the crystal tube's cross-section accommodates one cycle sub in each traffic direction simultaneously, with passing points at the junction nodes and the hub connections. Distributed because the fleet's individual vehicles are making individual transit decisions within the network's route options. And network because the decisions of each vehicle affect the network's total capacity utilization and the experience quality of the other vehicle's occupants. The coordination challenge is both a logistics problem and an experience design problem simultaneously. The logistics problem is throughput, matching the fleet's route assignments to the network's capacity to prevent the transit congestion that produces waiting times exceeding the experience's quality threshold. The experience design problem is social, ensuring that the separation between cycle subs and adjacent passage sections is sufficient to prevent the following sub's occupants from experiencing the leading sub as a visual obstruction rather than as the passage's geological and biological character. The visual obstruction concern is not trivial. The passage geometry's typical dimensions, the crystal tube's 2-meter interior diameter, the sub's hull's 1-meter cross-section, leave approximately 50 centimeters of clearance on each side of the sub at the center of the crystal tube. A second cycle sub following at close distance occupies the full visual field through the leading sub's hull in the following direction, replacing the aquifer's geological and biological character with another sub's hull. The following distance that allows the passage's full visual character to dominate the field of view rather than the preceding sub's hull is the design parameter the coordinating system's transit management layer maintains. The coordinating system's sub-separation management uses the electromagnetic roller's speed modulation, adjusting each sub's transit speed within the boulevard's operating speed range to maintain the minimum following distance, as the primary separation control. A sub that is gaining on the sub ahead of it in the same passage section receives a deceleration instruction that reduces its transit speed below the leading sub's transit speed until the separation has increased to the minimum design distance. A sub that has fallen below minimum following distance from the sub behind it receives an acceleration instruction that increases its transit speed to widen the gap. The human pedaling mode speed, determined by the occupant's pedaling cadence and the flywheel's kinetic energy accumulation, not by the coordinating system's speed instruction, is the separation management's challenge in the freshwater zone. Two cycle subs in pedaling mode in the same passage section are advancing at speeds the occupant's pedaling produces, which the coordinating system cannot directly control. The coordinating system's response is the scheduling. The transit management layer's route assignment protocol spaces cycle sub departures from the hub's docking ports at intervals calibrated to prevent two pedaling mode subs from entering the same passage section simultaneously. The spacing is conservative enough to allow for variation in pedaling cadences. The transit sub that pedals faster than the model predicted has additional clearance from the preceding sub's allocation. The coordination across the fleet produces what no individual sub's design can produce alone, the experience of being essentially alone in the aquifer. Not literally alone, the coordinating system knows the fleet's full distribution and the maintenance sub's positions and the autonomous harvest drone's routes. But experientially alone, in the sense that the aquifer visible through the sub's hull is the aquifer rather than the preceding sub's hull, and the acoustic environment through the hull is the aquifer's acoustic character rather than the preceding sub's propulsion system's sound. The fleet management's achievement is the individual experience of uncrowded access to a formation that many people are simultaneously accessing. The experience of uncrowded access is not guaranteed by low visitor numbers. It is engineered by fleet separation management that maintains the visual and acoustic isolation of each sub's transit regardless of the total fleet's instantaneous population. The visitor who has the uncrowded experience is not a visitor in a low-demand period. The visitor is any visitor whose transit was scheduled by the coordinating system's transit management layer with the separation that produces the uncrowded experience at any demand level within the network's capacity. The coordinating system is managing the experience as carefully as it manages the biology. The experience is infrastructure. The cycle sub's cultural legacy. The cycle sub is the first transportation vehicle in the history of human engineering that was designed for the specific purpose of helping the occupant understand a geological formation. Not to cross it, not to exploit its resources, not to achieve a destination on the other side of it. To understand it, to accumulate, through direct sensory engagement at the pace and scale the formation's dimensions provide, the specific kind of knowledge that only direct experience produces. This purpose is not inscribed on the vehicle. The vehicle does not explain itself. It produces its purpose through its design, the transparent hull that makes the formation visible, the flywheel's pace that makes the formation legible, the physical engagement that makes the formation experiential, the docking sequence that makes the formation architectural. The purpose is the experience the design produces, not the purpose statement anywhere printed on the hull. The cycle sub's cultural legacy, across the civilization's operating period, is the population of visitors who have experienced the aquifer from inside it, who know the cenote in the specific way that the cycle sub's transit through the freshwater zone's crystal tube network produces. This population grows with each transit, accumulates across the installation's operating life, and disperses into the surface world carrying the knowledge that the cycle sub's experience produced. The knowledge is not primarily factual. The facts, the halicline's depth, the cenote's geological age, the reef community's succession dynamics, the Bodo population's management program, are in the orientation materials. The knowledge the cycle sub produces is the knowledge of what it is like to be inside a geological formation that has been developing for 66 million years, moving through it at the pace the flywheel's steady output produces, watching its biology change through the transparent hull, feeling its temperature stratification in the water's thermal transmission through the hull's polymer composite, arriving inside its inhabited structures through the wetlock's pressure equalization sequence. This knowledge changes what the person who carries it is likely to do when confronted with decisions that affect geological formations, freshwater systems, and biological communities. Not because the cycle sub teaches an environmental lesson, it teaches no lesson. But because the knowledge of what it is like to be inside a living geological system changes the person's relationship to geological systems that they encounter after the cycle sub experience. The formation encountered from inside, at the formation's own pace, is a formation that the visitor has a relationship with rather than a knowledge of. The relationship is different from the knowledge. The relationship is what the cycle sub produces. A civilization that is building a 1,000-year relationship with its formation is also building, through every cycle sub transit it authorizes, a population of surface world visitors who have had a fraction of that relationship themselves, who understand, in whatever partial and temporary way a transit through the freshwater zone produces, what it means to be inside a formation rather than on top of it, to move through geological time at the pace the flywheel produces, to see the biological community through the transparent hull at the distance the passage geometry creates. The civilization's relationship with the formation is private, conducted in the deep galleries, in the terraform operator's morning monitoring review, in the anchor zone's acoustic characterization data, in the genetic census's drift monitoring results. The visitor experience is the formation's relationship with the surface world, the interface through which the formation's existence becomes legible to people who will never live in it but who can be changed by having been inside it. The cycle sub is the interface. The pedaling is the engagement. The aquifer is the formation. The experience is the civilization's gift to the surface world that the formation has been offering for 66 million years without any delivery mechanism. Pipe Dream built the delivery mechanism. The cycle sub delivers. Cross-references, Part 2, CH1, Cities Made of Light, Part 2, CH4, The Crystal Tube Standard, Part 3, CH4, Underground Boulevards, Part 5, The Engineered Ecosystem, Part 6, CH2, Scaphanders for Everyone, Part 6, CH3, The Underground Safari, Part 7, CH5, The Blackout Protocol. For cycle sub hull material specification and co-extruded laminate fabrication protocol, see Appendix D, Construction Operations Manual. For wetlock docking sequence protocol and pressure equalization confirmation thresholds, see Appendix D, Construction Operations Manual. For Avalo system buoyancy trim calibration and battery failure emergency protocol, see Appendix D, Construction Operations Manual. For passenger training protocol and transit authorization confirmation procedure, see Appendix H, Governance Operations Manual. For fleet separation management parameters and route assignment scheduling protocol, see Appendix D, Construction Operations Manual. Pipe Dream. Part 6, The Visitor Experience. Chapter 2, Scaphanders for Everyone. The history of human diving is the history of the gap between what the human body can survive underwater and what the human mind wants to go underwater to see. The body's gap is narrow. 10 meters of seawater imposes 1 additional atmosphere of pressure on every surface of the human body, and the body tolerates this without extraordinary intervention. The tissues compress slightly, the sinuses equalize with training, the oxygen partial pressure in the lungs increases to a level the blood absorbs more efficiently than at the surface. 20 meters is manageable for a trained breath-hold diver. 30 meters requires caution. Beyond 40 meters, the nitrogen in compressed breathing air begins dissolving into the blood and tissues at concentrations that produce narcosis, the anesthetic effect of nitrogen under pressure, and beyond 60 meters with compressed air the oxygen partial pressure approaches the central nervous system toxicity threshold. The body's gap between tolerable and dangerous is, historically, about 60 meters with compressed air and training. The mind's gap is larger. The mind wants to go where the underwater environment's complexity and beauty extend without regard for the body's physiological tolerances, down into the geological formations that the surface world's diving literature describes in language that consistently exceeds what any photograph can convey, into the cenote's halocline zone and beyond it into the saltwater column's darkness, into the passage geometries that no human body has occupied before and that the drill bit of curiosity requires. To be seen and touched and understood through the specific sensory register that being physically present in a space produces. The history of diving technology is the history of attempts to close the gap, to extend the body's tolerable range toward the mind's desired range. The scaphander is one of the earliest formal attempts, the 19th century's heavy helmet and canvas suit that allowed the diver to breathe surface-pumped air from a flexible supply hose while the helmet's rigid structure protected the head and face from the water column's pressure, and the weighted boots and belt maintained the diver's vertical orientation on the seafloor despite the suit's buoyancy. The 19th century scaphander was effective at closing the gap by about 20 meters, enough for harbor work, for salvage operations, for the coastal fisheries exploitation that the industrial era's maritime economy required. It was not effective at closing the gap for exploration, for the observation of undisturbed biological communities, or for the kind of spatial understanding that requires the diver to be mobile and self-directed in 3 dimensions rather than tethered to a surface pump and weighted to vertical stability. The Pipe Dream scaphander closes the gap to the full depth of the freshwater zone and the halocline's upper boundary, approximately 30 meters of total depth range in the managed cenote environment, with a different approach from the 19th century's weighted suit and surface hose. Not a larger, heavier, more powerful version of the same technology. A different technology organized around a different relationship between the diver's body and the aquifer environment that the diver's mind wants to encounter. The design philosophy. The surface world's recreational diving equipment, the buoyancy compensating device, the regulator, the tank, the wetsuit, the fins, the mask, was designed around the premise that the diver is a land organism temporarily visiting an aquatic environment, and the equipment's function is to make the visit survivable. The BCD manages buoyancy. The regulator manages breathing gas. The tank stores the breathing gas. The wetsuit manages thermal exposure. The fins manage propulsion. The mask manages vision. Each component manages one specific problem that the aquatic environment creates for the land organism's visit. The system works, within its limitations, and those limitations are significant. The diver wearing the full equipment configuration has a respiratory apparatus attached to their face that changes their breathing mechanics, adds weight to their body that the BCD must compensate for with compressed air buoyancy, imposes a posture constraint from the tank's center of gravity above and behind the diver's center of mass, and produces the hydrodynamic drag of a human body wearing equipment designed by engineers who were thinking about component function rather than fluid dynamics. The result is a diver who is survivable in the aquatic environment but not graceful in it, who can see and breathe but moves through the water with the efficiency of a human body wearing equipment that was not designed for graceful movement. The Pipe Dream scaphander was designed around a different premise: the visitor to the aquifer is not a land organism temporarily visiting. They are a person who has descended from the surface tier's orientation galleries through the freshwater zone's longevity galleries and into the managed biological community of the synthetic reef's mid-succession zone, and who has been briefed on the cenote's biological and geological character by the terraform operator's guided orientation session, and who is now preparing to leave the crystal tube's atmospheric enclosure for a direct encounter with the freshwater zone's water column. Not a visit to an alien environment. An encounter with the formation that the civilization inhabits, an encounter that the person has been prepared for and is about to enter as a participant rather than as a tourist in protective equipment. The scaphander's design premise is participation. The equipment should make the person a graceful participant in the aquifer's environment rather than a survivable visitor to it. Graceful participation requires that the equipment manage the aquifer's physical constraints, the pressure, the breathing gas, the buoyancy, the thermal management, the vision, while adding as little hydrodynamic drag, as little visual obstruction, and as little postural distortion as the physics of managing those constraints allows. The design premise does not produce lightweight equipment. Managing the aquifer's physical constraints requires substantial engineering. The scaphander is not a thin membrane suit with a small rebreather attached. This would be the lightest possible configuration, and it would fail at the first component failure event in a way that the Terraform operator's safety protocol cannot accept. The scaphander is substantial equipment that manages the constraints with the redundancy and failure mode legibility that the formation environment's consequences require, while organizing that substantial engineering around the participant's body with the minimum postural distortion and the maximum fluid dynamic efficiency that the engineering's constraint management allows. The helmet. The scaphander helmet's primary material is alone, the same aluminum oxynitride ceramic that the deep gallery's structural panels and the Wetlock's docking port cones are made from. Mohs hardness 9, optically transparent across the visible and near UV range, immune to the hydrogen sulfide chemistry that the halocline zone's lower boundary begins introducing at detection concentrations. The scaphander is not rated for the anoxic zone's full H2S concentrations. The full alone panel protection at anoxic zone deployment requires the inhabited gallery's full atmospheric management infrastructure, not the scaphander's rebreather. The scaphander operates in the freshwater zone and the halocline's upper boundary, the depth range where H2S is detectable but below the physiological impact threshold for the scaphander's rated exposure duration. The helmet's optical geometry was specified from the human visual system's field of view requirements rather than from the geometry that minimizes the alone material mass, the design approach that would produce the smallest, lightest helmet at the cost of the visual field the participant requires. The human visual system's functional field of view, the range across which the eye can acquire and interpret visual information without requiring head movement, is approximately 180 degrees horizontally and 130 degrees vertically. The conventional diving mask's field of view through the lens system is approximately 60 degrees horizontally at the lens distance from the eye that the mask's face seal geometry produces. The scaphander's alone visor's curved geometry produces an unobstructed field of view of approximately 150 degrees horizontally and 100 degrees vertically, the maximum the alone fabrication process's achievable dome geometry produces before the optical distortion at the visor's periphery exceeds the visual comfort threshold that the coordinating system's passenger experience monitoring data specifies from the scaphander's field trial period. The wide visual field is the scaphander's most important single design parameter, and understanding why requires understanding the difference between seeing the aquifer through a conventional diving mask and seeing it through the scaphander visor. The conventional mask's 60-degree horizontal field sees the aquifer as a view through a porthole. The formation around the edges of the visual field is cut off by the mask's frame, and the diver's perception of the formation is of something they are looking at through an opening rather than of something they are inside. The scaphander visor's 150-degree horizontal field sees the aquifer as an environment. The formation is present in the near-peripheral visual field simultaneously with the central visual field, producing the spatial perception of being surrounded by the formation rather than looking at it. The person inside the scaphander is inside the aquifer. The mask's person is visiting the aquifer. The alone dome's curvature is not optically neutral. A curved refracting surface between two media of different refractive indices produces image distortion proportional to the angle of incidence at the surface. The alone's 1.79 refractive index, significantly higher than the freshwater's 1.33, produces distortion at the visor's periphery that increases with angular distance from the visor's optical axis. The distortion is managed by the visor's aspherical geometry. Rather than a spherical dome whose radius is constant, the visor's curvature is continuously varied across the dome's extent to minimize the distortion at each angular position relative to the expected eye position inside the helmet. The aspherical optimization was performed by the coordinating system's optical design module against the anthropometric eye position data from the founding installation's scaphander fitting records, the actual eye positions of the actual people who wore the scaphanders in the fitting sessions, not the idealized eye position that a generic optical specification would use. The visor is optimized for the distribution of actual human faces, not the theoretical average face. The helmet's internal atmosphere is maintained at ambient pressure, the pressure at the scaphander's current depth, which increases at approximately 0.1 bar per meter of freshwater depth. The internal atmosphere is the scaphander's nitrox breathing mixture, enriched oxygen fraction adjusted by the coordinating system's scaphander management layer to maintain the oxygen partial pressure within the therapeutic range that the scaphander's operating depth profile specifies. The nitrox delivery system is the rebreather, the closed-circuit breathing apparatus that recirculates the exhaled gas through a CO2 scrubbing canister, replenishing the consumed oxygen from the nitrox supply cylinder, and returns the scrubbed, oxygen-replenished gas to the breathing circuit without releasing exhaled bubbles to the cenote water column. The rebreather's advantages over the open-circuit regulator that conventional recreational diving uses are specific to the Scaphander's design premise. The rebreather produces no exhaled bubbles, the silent, bubble-free underwater presence that the aquifer's biological community finds less disturbing than the intermittent bubble streams that open-circuit diving produces. The Bodo population's behavioral research record includes the observation that approaching Bodo individuals tolerate Scaphander divers at closer approach distances than open-circuit divers, a difference that the behavioral monitoring attribute to the exhaled bubble stream's acoustic signature. The intermittent turbulent noise of ascending bubbles is within the Bodo's acoustic sensitivity range and produces an avoidance response at approach distances where the Scaphander diver's quieter presence does not. The rebreather also extends the dive duration available from the same gas supply. The closed-circuit recirculation uses the oxygen supply only for the consumed fraction rather than for the full exhaled volume, so the same oxygen supply provides several times the dive duration of an open-circuit system drawing from the same volume. Longer dive durations allow the participant to accumulate the formation's temporal character, to observe the synthetic reef's grazer community's feeding cycles, to wait for the Bodo population's curiosity-driven approach to the stationary Scaphander diver, to watch the aquaculture city's harvest drone's morning collection route through the bioreactor columns. The extended duration is not a luxury feature. It is the time the formation requires to reveal itself at the pace it operates on, not the pace the surface world's compressed air supply dictates. The suit. The Scaphander suit's thermal management is the primary engineering constraint between the helmet and the propulsion system. The freshwater zone's temperature decreases from the surface tier's approximate 25 degrees Celsius toward the halicline's 15 degrees Celsius at maximum freshwater zone depth. The human body's thermoregulatory system at rest produces heat at a rate sufficient to maintain core temperature at the surface tier's ambient temperature without assistance. The body is producing more heat than the surface tier's water column at 25 degrees conducts away through the unprotected skin. At the halicline boundary's 15 degrees, the body's resting heat production is insufficient to prevent core temperature decline over the dive duration at which the Scaphander's operational protocol is rated. The suit's thermal management layer is a variable conductivity composite, a material system whose thermal conductivity between the body's skin surface and the cenote water column is controlled by the suit's internal fluid circulation system. The composite's matrix carries microchannels of circulating fluid through the suit's full thickness, from the integrated pump in the suit's torso section, through the microchannel network in the extremity sections, back to the pump. The fluid's flow rate determines the thermal conductivity. At maximum flow, the fluid rapidly transfers heat from the microchannel network's inner surface, at skin temperature, to the outer surface, at cenote water temperature, producing high thermal conductivity and maximum cooling. At minimum flow, the fluid's heat capacity and low flow rate trap the body's heat production in the boundary layer between the skin and the microchannel network's inner surface, producing low thermal conductivity and thermal insulation. The coordinating system's Scaphander management layer controls the fluid circulation rate from the core temperature sensor in the helmet's internal atmosphere, the core temperature proxy that the ear canal temperature measurement provides at the accuracy the hypothermia risk management protocol requires. If the core temperature measurement trends below the warning threshold, the circulation rate decreases, reducing heat loss. If it trends above the comfort threshold, a less likely scenario but possible during physical exertion at the shallower freshwater zone depths, the circulation rate increases, enhancing heat dissipation. The variable conductivity system allows the same suit to operate in the surface tier's 25-degree ambient and the halicline boundary's 15-degree ambient without requiring the participant to don or doff layers. The suit manages the thermal gradient actively, maintaining the participant's thermal comfort across the full freshwater zone depth profile without requiring the participant to manage thermal exposure. The suit's exterior surface is specified for two simultaneous properties: hydrodynamic smoothness, the minimum surface roughness that the fabrication process achieves, and optical neutrality in the cenote water column. The optical neutrality specification requires that the suit's exterior surface in the cenote water's illumination appears to the biological community as a smooth, non-threatening, non-prey resembling object rather than as a visual stimulus that triggers predator avoidance, prey pursuit, or aggressive territory defense in the aquifer's biological community. The suit's coloration was specified after the coordinating system's biological monitoring analysis of the biological community's visual response to different color stimuli, the color and pattern combination that produced the minimum avoidance and maximum tolerance from the Bodo population, the cave fish species, and the invertebrate community was the suit's exterior specification. The suit's coloration is not camouflage in the military sense. It is not designed to prevent detection. It is designed to produce the minimum behavioral disruption from detection. A scaphander that the aquifer's biological community ignores is a scaphander that allows the participant to observe the biological community's undisturbed behavior. The undisturbed behavior is what the scaphander experience is intended to produce encounter with. The propulsion system. The scaphander's propulsion is the participant's most significant physical engagement with the aquifer outside the cycle sub's pedaling. The conventional diving fin, the rubber blade attached to the foot that the diver kicks to produce forward thrust, is the surface world's aquatic propulsion standard for personal diving. It works adequately, the kick produces thrust, the diver advances. It works poorly by the hydrodynamic analysis that the scaphender's design premise requires. The kick cycle's alternating forward and downward thrust vectors produce a bobbing motion that displaces the diver vertically as well as horizontally. The asymmetric leg extension from the kicking motion distorts the body's horizontal posture, and the large surface area of the conventional fin displacing water creates turbulence that the biological community's lateral line systems detect and respond to as a large organism's movement signature. The scaphender's propulsion is a forearm-mounted thruster array, a pair of symmetric thruster units, one attached to each forearm at the wrist end, oriented to produce thrust in the direction the arm is extended. The participant extends the arm in the direction they want to move. The thruster array fires in the extended direction. The body follows the arm's direction of extension without the postural distortion of the leg kick. The arm-mounted orientation allows three-dimensional maneuvering that the leg kick's horizontal plane-dominant thrust vector cannot produce as elegantly. To ascend, the participant extends both arms upward. To descend, both arms downward. To rotate, one arm to the left and one arm to the right simultaneously. To hover in three-dimensional position without current, both arms aimed horizontally in opposition, canceling each other's thrust vectors and producing zero net horizontal velocity while the buoyancy management system maintains the vertical position. The thruster array's acoustic signature, the impeller's rotation in the thruster housing's water channel, is in the frequency range that the acoustic zoning protocol manages for biological community compatibility. The thruster's sound is not absent. Impellers moving water produce hydrodynamic noise at the impeller blade passing frequency. The thruster housing's acoustic dampening material reduces the impeller noise to the level that the coordinating system's biological acoustic monitoring identifies as below the Boto population's threshold for behavioral response at the approach distance the scaffender experience protocol specifies as the closest permitted approach. The thruster is quiet enough that the Boto does not avoid it. The Boto does not avoid it, so the participant does not chase it. The approach distance the protocol specifies is the distance at which the undisturbed Boto approaches of its own behavioral motivation. The buoyancy management integrated in the scaffender suit's torso section is a scaled-down version of the Cycle Sub's Avalo system, a carbon fiber pressure vessel with internal rubber bladder, filled with compressed nitrox from the main supply cylinder, manually adjustable through the wrist-mounted control interface. The participant adjusts the bladder inflation to achieve neutral buoyancy at their target depth, the specific freshwater column depth that the protocol has assigned to the participant's session based on their medical profile, their training completion record, and the Terraform operator's depth assignment recommendation. Neutral buoyancy at the target depth allows the thruster array to direct all its thrust toward horizontal and rotational maneuvering rather than compensating for positive or negative buoyancy. The participant hovers effortlessly at the target depth and moves where the arms direct. The scaffender's relationship to the longevity program. The scaffender experience at the halocline zone's therapeutic pressure range, approximately 1.3 to 1.5 atmospheres, is a component of the longevity program's therapeutic protocol for enrolled guests whose medical profile indicates benefit from active rather than passive pressure exposure. The distinction between passive and active therapeutic pressure exposure is the longevity program's clinical distinction between the rest gallery and the scaffender session. The rest gallery's therapeutic benefit comes from sustained exposure at therapeutic pressure in a low activity state that allows the body's autonomous repair processes to operate at enhanced efficiency. The scaffender session's therapeutic benefit adds to the passive exposure's benefit the physiological effects of moderate aerobic exercise in the therapeutic pressure and nitrox atmosphere, the enhanced oxygen delivery to working muscles, the thermoregulatory response to water immersion, the proprioceptive and vestibular stimulation of three-dimensional movement in the water column. The combined effect of pressure, enriched oxygen, moderate aerobic exercise, and water immersion on the longevity program's key biological indicators has been measured in the founding installation's longitudinal dataset. The scaffender session adds a measurable increment to the week-over-week telomere extension rate, above the passive gallery exposure alone, for guests whose medical profile indicates aerobic exercise tolerance and whose depth assignment places them in the therapeutic pressure range during scaffender sessions. The increment is smaller than the cumulative effect of the passive gallery exposure across the enrolled period, but it is measurable, consistent, and adds to the program's total biological impact for the guest who participates in the scaffender sessions alongside the gallery enrollment. The coordinating system's medical monitoring layer tracks the enrolled guest's response to scaffender sessions individually. The weekly blood work that follows each scaffender session is compared to the weekly blood work following gallery-only exposure weeks to measure each individual session-specific increment. The individual increment data informs the session frequency recommendation. Guests whose blood work shows significant per session increment receive the maximum session frequency the protocol allows for their aerobic fitness level. Guests whose blood work shows minimal per session increment are recommended toward gallery-only exposure during the remaining enrolled period. The scaffender session's medical function is inseparable from its experiential function. The same session that delivers therapeutic pressure and enriched oxygen in a moderate aerobic exercise context also delivers direct encounter with the formations biology and geology that the cycle subs transit through the crystal tube produces at one remove. The scavenger participant is not inside a transparent enclosure encountering the formation through a transparent wall. The participant is inside the formation, immersed in the cenote water column, breathing the enriched nitrox through the rebreather circuit, hovering at neutral buoyancy in the freshwater zone's mid-column depth, watching the Boto populations approach and retreat through the alone visor's wide field of view. The therapeutic function and the experiential function are the same session. The same depth assignment that places the participant in the therapeutic pressure range for the bloodwork's monitored response also places the participant in the freshwater zone's most biologically active depth band, the mid-column zone where the aquaculture city's suspended cages concentrate the most complex trophic interactions and where the Boto population's prey concentration draws the population's activity patterns. The therapeutically optimal depth is the experientially optimal depth. The clinical assignment and the experiential design converged on the same depth parameter because both were calibrated against the same formation conditions. Equipment availability. The scavenger's design complexity and material specifications, the alone dome helmet, the variable conductivity suit, the closed-circuit rebreather, the arm-mounted thruster array, the integrated buoyancy management, produce a piece of equipment whose unit cost significantly exceeds the cost of conventional recreational diving equipment. The founding charter's visitor experience philosophy, documented throughout Part 6 as the principle that the experience's quality should not be limited by the visitor's resources, requires a response to this cost that is not the equipment's simplification, which would compromise the design premises requirements, or the equipment's limitation to high-income visitors, which would reproduce the surface world's access inequality in the cenote's exceptional environment. The response is the equipment pool. The scavenger fleet is part of the installation's infrastructure, owned by the Principality's commons, maintained by the maintenance protocol, available to all enrolled participants regardless of their individual financial capacity. The scavenger experience is included in the longevity program enrollment standard access. It is not an upgrade. It is not an add-on. It is part of what the longevity program offers to all enrolled participants, because the coordinating system's medical monitoring data indicates that all enrolled participants within the aerobic fitness range the scavenger protocol requires can benefit from the session's contribution to the program's total biological impact. The equipment pool's maintenance is the maintenance protocol's responsibility, not the participants'. The coordinating system's maintenance scheduling for the scavenger fleet operates on the same condition-based maintenance model that governs all other infrastructure components. Each scavenger unit's operational parameters are monitored at each session's pre-dive equipment check. The check data is integrated into the coordinating system's equipment health monitoring layer, and each unit's maintenance schedule is driven by its condition indicators rather than by calendar intervals. The pre-dive equipment check is the participant's first direct engagement with the scavenger, the session that begins in the equipment room at the participant's assigned depth tier's hub level, where the coordinating system's equipment management display walks the participant through the check procedure that verifies the helmet seal, the rebreather circuit's CO2 scrubber canister's remaining capacity, the thruster array's battery state, the buoyancy management system's compressed gas pressure, and the integrated thermal management system's fluid circulation operational status. The participant performs the check under the equipment room's Terraform operator's supervision, not as a formality but as the safety verification that the scavenger's enclosed atmospheric system requires as the last human-verified checkpoint before the participant enters the water column. The check structure mirrors the cycle sub's Avalo training requirement. The participant who has verified the equipment's operational status through direct manual inspection of each system has a different relationship to that equipment's reliability than the participant who was handed the equipment and told it was checked. The relationship is the foundation of the autonomous operation that the scavenger's design premise requires. A participant who trusts their equipment because they have verified it personally is a participant who can direct their attention to the formation rather than to anxiety about the equipment. The approach protocol. The scavenger experiences encounter with the cenote's biological community, the Boto, the aquaculture gallery species, the synthetic reefs grazer community, the cave fish species that the biological monitoring network census tracks in the unmanaged limestone surfaces biological community, is governed by the approach protocol that the coordinating system's biological management layer specifies for each species encounter type. The approach protocol is not a set of prohibitions. It is a set of distances and speeds and postures that the biological monitoring's behavioral data identifies as the conditions under which the biological community's behavior is undisturbed by the scavenger's presence. The Boto approach distance is the most precisely specified. The behavioral monitoring's analysis of individual Boto responses to scavenger encounters has produced a distance-behavior relationship that identifies the distance at which the Boto transitions from ignoring the scavenger, approach distance greater than 5 meters, to curiosity investigation, 3 to 5 meters, to potential avoidance, less than 2 meters. The protocol specifies a minimum approach distance of 3 meters, within the curiosity investigation zone, close enough for the participant to observe the Boto's behavior without triggering the avoidance response that closer approach produces. The protocol's 3-meter minimum approach to the BOTO is enforced by the coordinating system's scavenger management layer through the equipment's integrated proximity monitoring. The scavenger helmet's alone dome carries an ultrasonic proximity sensor network that measures the distance to any biological object larger than the BOTO's minimum body size at the detection threshold's minimum size. When the proximity sensor detects a BOTO at 3 meters or less, the thruster array's directional capability is restricted by the coordinating system's remote management signal. The thruster can produce thrust in any direction that increases the distance to the detected BOTO but cannot produce thrust in any direction that decreases the distance below 3 meters. The restriction is automatic and not overridable by the participant. The restriction's existence is not disclosed to the participant as a constraint on their autonomy. It is disclosed as a design feature that protects the encounter. The thruster's approach restriction prevents the participant from inadvertently approaching the BOTO closer than the behavioral research indicates produces avoidance, preserving the curiosity investigation behavioral state that the close encounter the participant wants to have depends on. The restriction prevents the participant from destroying the experience it is protecting. The BOTO's curiosity approach, which only occurs when the scavenger maintains the correct distance, is what the participant wants. The restriction maintains the distance that produces the approach. The cave fish species approach protocol is less precisely specified. The cave fish's behavioral responses to scavenger encounter are highly variable across species, and the biological monitoring's behavioral data does not support the individual response level precision that the BOTO protocol achieves. The cave fish protocol is specified as a general behavioral state indicator. If the participant observes rapid retreat, sudden illumination response, the eye spot display that several cave fish species produce under threat conditions, or schooling collapse from an aggregated school into dispersed individuals, the approach has reached the threshold where the species is disturbed. The participant should immediately reverse thruster direction and increase distance to the fish community. The general indicator approach places the judgment with the participant, requires the participant to recognize the behavioral signals that the training protocol has prepared them to identify and to respond appropriately without the coordinating system's automated restriction. The training protocol's preparation for this judgment is the significant component of the scavenger's pre-session orientation, not a lecture about which species to avoid and which to approach, but a visual training session using the biological monitoring network's archived behavioral footage of scavenger encounters with each cave fish species, walking the participant through the specific behavioral signals that indicate disturbance and the approach response each signal requires. The training prepares the participant to be a competent ecological participant, a person whose presence in the aquifer improves with each session's experience accumulation, whose encounter with the biological community becomes progressively less disturbing as the participant's behavioral sensitivity improves and the biological community's accumulated experience with the scavenger program's participants normalizes the scavenger's presence. The experienced scavenger participant is less disturbing to the biological community than the first session participant, because the experienced participant reads the community's behavioral signals more accurately and responds to them more promptly. The scavenger program improves with use, not only in the participant's medical outcomes but in the participant's ecological competence. The encounter. The participant who exits the wetlock's outer hatch into the freshwater zone's water column for the first time experiences the transition that no preparatory description fully captures, the shift from the enclosed atmospheric space of the crystal tube network to the open water column of the cenote, where the full spatial volume of the freshwater zone, all 18,000 cubic meters of it, visible from the participant's position in the mid-column zone in all 3 dimensions through the alone visor's 150-degree field, is present simultaneously in the visual field. The crystal tube's interior is a cylinder 2 meters in diameter. The freshwater zone's open water column is a cylinder 40 meters in diameter and 15 meters deep. The visual transition from one to the other is a spatial transition from the enclosed to the infinite, the mind's spatial model of its environment expanding from the tube's confining cylinder to the cenote's full spatial volume in the time it takes the participant to pass through the wetlock's outer hatch and orient in the open water. The transition is not overwhelming in the positive experience it produces. It is not a view, in the sense of a thing seen from a distance. It is a space, in the sense of a thing inhabited in 3 dimensions simultaneously. The cenote is not visible from the participant's position. The participant is inside the cenote. The visor's 150-degree field does not show the cenote the way a window shows a landscape. It shows the cenote the way a clearing shows a forest to someone who has stepped into the clearing from a narrow path. The BOTO that approaches from the left and above, navigating the passage between the aquaculture gallery's outer cage surface and the crystal tube wall in the mid-column zone's upper depth band, is at 4 meters when the participant first sees it, within the curiosity investigation zone, not yet triggering the approach restriction. The BOTO's head orientation at the first observation, turned 90 degrees from the body axis toward the participant, the unfused cervical vertebrae's range of motion expressed in the full 90-degree head turn that allows the BOTO to direct the echolocation beam at the participant while maintaining the body's horizontal swimming orientation. The echolocation is not audible to the participant, the click train's frequency is above the human auditory threshold. It is detectable through the scavenger helmet's acoustic sensor as data displayed on the helmet's interior peripheral display, a graphic indication that the boat's echolocation is active and directed toward the participant's position. The participant holds position, the thruster at neutral, the buoyancy management at neutral, the body stationary in the three-dimensional space. The boat approaches to 2.7 meters, inside the approach restriction's 3-meter threshold, and the thruster management's automatic restriction activates, preventing the participant from reducing the distance further. The boat is not retreating. At 2.7 meters, the boat's behavior is at the boundary between curiosity investigation and close approach, the behavioral state the monitoring research identifies as the most specific to individual boat rather than population-level behavior, the state where the boat's individual curiosity and individual history with scavenger encounters produces the widest variation in behavioral response across individuals. This particular boat, known to the Biological Monitoring Network's individual recognition database by the pigmentation pattern on its left flank, 12 individual encounters with scavenger participants recorded in the behavioral database across the current season scavenger program, approaches to 2.4 meters, pauses, produces 2 burst pulse vocalizations that the acoustic sensor registers as the social contact call this individual emits at approach distances with recognized regular encounter humans, and turns its full body toward the participant in the presentation posture that the behavioral research associates with mutual investigation. The participant has not done anything to produce this. The participant held position. The boat approached. The encounter is the boat's decision. The scavenger's design, the approach protocol, the thruster restriction, the behavioral monitoring, the individual recognition database, all of this exists to make the space in which the boat's decision can be made the decision the boat wants to make. The boat remains at 2.4 meters for 23 seconds. The behavioral monitoring's temporal analysis of this encounter will later identify this as a sustained individual investigation episode, longer than the median duration for curiosity investigation encounters, shorter than the median duration for play encounters that the boat initiates with familiar participants after multiple sessions. A 23-second encounter between a wild cetacean and a scavenger-equipped human participant in an open water column, at the cetacean's choice of approach distance and departure timing, with no human initiative and no equipment restriction preventing the cetacean from departing at any moment. This is the encounter the scavenger was designed to make possible. The boat turns and departs toward the aquaculture gallery's far side, tracking the cage wall with the echolocation active in the environmental mapping mode, scanning the cage geometry for the fish community's distribution pattern, assessing the prey opportunity. The morning's population data has changed since the last scan. The encounter is over. The participant remains at neutral hover in the mid-column zone, watching the boat's departure. The peripheral display registers the encounter's end timestamp. The behavioral data is transmitted to the monitoring network. The individual recognition record is updated. The participant has been inside the aquifer. The boat has investigated the participant and moved on. The cenote continues its business. The scavenger's place in the civilizational argument. Part VI's visitor experience documents the civilization's relationship with the surface world, the interfaces through which the formation's exceptional environment becomes accessible to people who do not live there and will not live there, who are passing through on the schedule the longevity program or the adventure program or the transit connection has produced. The scavenger is the most intimate of these interfaces. The cyclosub's encounter with the formation is mediated by the transparent hull. The underground safari's encounter is mediated by the crystal tube's distance and the guide's narration. The scavenger's encounter is unmediated in the specific sense that no material barrier exists between the participant's body and the cenote water. The alone visor and the suit's exterior surface are in direct contact with the cenote water, which is in direct contact with the formation's biological community, which has no boundary between itself and the water column it inhabits. The participant is as close to the formation as the formation permits. The 3-meter approach restriction is not the formation's limit. The formation does not limit approach distance. It is the civilization's safety margin between the participant's direct encounter and the biological community's behavioral response to that encounter. The civilization interposes the 3-meter margin not to protect the participant from the formation but to protect the formation's behavioral ecology from the participant's proximity. The scavenger is not a protective device. It is an enabling device, the technology that makes the encounter possible by making the participant's body survivable in the conditions the encounter requires, while organizing the survival technology around the participant's body with the minimum interruption of the participant's sensory engagement with those conditions. The participant breathes the nitrox through the rebreather and does not notice the rebreather. The participant maintains neutral buoyancy through the suit's system and does not manage the buoyancy consciously. The participant extends their arm and moves in the direction their attention wants them to go and does not operate a propulsion system consciously. The scavenger disappears when it is working correctly. The participant is inside the aquifer. The formation is what the visor shows. The boat is what approaches. The formation's temperature is what the suit's variable conductivity manages. The therapeutic pressure is what the depth position provides. The encounter is what is happening. The technology produces the experience by producing the conditions for the experience and then stepping aside. The civilization's most sophisticated engineering achievement in the visitor experience domain is not the scaphender's alone dome or the variable conductivity suit or the magnetic coupler or the rebreather circuit. It is the design philosophy that organized all of these around the premise that the technology's purpose is to disappear into the experience it enables, rather than to present itself as the experience. The scaphander is transparent to its own existence. The formation is what is left when the technology has done its job. The formation has been here 66 million years. The participant is here for 40 minutes. The scaphander makes the 40 minutes the formation's 40 minutes, conducted in the formation's water column, at the formation's biological community's pace, with the formation's apex predator's decision about when to approach and when to leave. The technology serves the formation. The formation receives the participant. The participant leaves with the formation's 40 minutes inside them, the specific kind of knowing that no secondary experience can replace and no amount of documentation can produce. The scaphander makes this possible. That is what it is for. Cross-references, Part 2, CH3, Materials that let civilization disappear, Part 3, CH5, Skyscrapers beneath the canopy, Part 5, CH3, Pink dolphins, Part 5, CH5, Synthetic reefs, Part 6, CH1, Pedal submarines, Part 6, CH3, The underground safari, Part 7, CH5, The blackout protocol, Part 11, CH2, The nitrox galleries, Part 11, CH3, Telomere economics. For scaphander equipment pool maintenance protocol and pre-dive equipment check procedure, see Appendix D, Construction Operations Manual. For BOTO approach distance specification and thruster management proximity restriction parameters, see Appendix F, Biological Operations Manual. For longevity program scaphander session frequency recommendation protocol and session-specific bloodwork analysis methodology, see Appendix F, Biological Operations Manual. For participant training protocol visual behavioral indicator library and cave fish species encounter response guidance, see Appendix H, Governance Operations Manual. Pipe Dream. Part 6, The Visitor Experience. Chapter 3, The Underground Safari. The safari's original context was colonial. The word comes from the Swahili by way of the Arabic, a journey, specifically a journey through territory that the traveler considers wild and the territory's inhabitants consider home. The colonial safari's defining relationship was between the observer and the observer in the vehicle, elevated, mobile, equipped with the optical instruments that collapsed the distance between their position and the animals, the observed on foot, at ground level, going about the business of being an animal in its habitat, ignorant of or indifferent to the observation. The relationship was not mutual. The animal did not choose to be observed. The observer chose to observe. The relationship produced a specific kind of knowledge, the knowledge of watching something that does not know it is being watched, from a position of safety and mobility that the watched animal cannot access, through optical instruments that exceed the unaided eye's resolving capability at the distances the vehicle maintains. This knowledge is genuine, it is the knowledge that wildlife biology accumulated through exactly this observational relationship, producing the behavioral datasets and ecological understandings that conservation science is built on. But it is not the knowledge of encounter. It is the knowledge of observation. The pipe dream underground safari has the same structural relationship, observer in a vehicle, moving through the territory's observed biological community, and produces something different from the colonial safari's observational knowledge. Not because the relationship has been altered. Because the territory has. The colonial safari's wild territory is the land animal's territory, the grassland or the jungle or the savanna that the observed animal inhabits in conditions that the observer's vehicle cannot enter without altering. The vehicle's presence alters the territory. The animal's awareness of the vehicle changes the animal's behavior. The knowledge produced is the knowledge of an observed animal in the presence of an observer, potentially different from the knowledge of the animal in the observer's absence. The pipe dream underground safari's territory is the cenote's geological and biological interior, a space that the cyclosub's crystal tube traverse makes accessible without entering, in the specific sense that the crystal tube's transparent hull separates the observer's atmospheric position from the territory's aquatic conditions while the hull's transparency makes the separation physically negligible from the observational perspective. The biological community outside the hull does not register the observer's presence at the scale of the crystal tube's full external surface. The tube wall is already present in the formation, already colonized by the synthetic reef community, already part of the cenote's visual landscape that the BOTO's echolocation maps and the Ancistrus vitreous colonies maintain. The observer inside the tube is inside an object that the formation has already accepted. The observer is not new to the territory. The object they are inside is not new to the territory. The safari observes an environment that has not changed its behavior to accommodate the observation. The knowledge produced is the knowledge of a biological and geological system operating in its normal conditions, viewed from inside an object the system has incorporated into its normal conditions. This is not the colonial safari's knowledge. It is something the colonial safari's relationship with its territory could not produce. What the safari is. The underground safari is a guided transit, a cycle sub or a specialized larger capacity transit pod carrying up to 8 participants plus one terraform operator guide, following a route through the freshwater zone's crystal tube network that has been curated for the current biological and geological conditions at the current season's phase, at the current halocline depth, at the current state of the aquaculture city's production cycle, at the current synthetic reef succession stage, and at the current Bodo population's activity pattern. The route is not fixed. The guide's route selection for each safari session reflects the current formation's conditions, what the formation is offering at this specific moment rather than what the safari route's map specifies as the planned itinerary. The map exists. The terraform operator's route selection that morning reflects the biological census's overnight update, the halocline sensor network's current depth reading, the Bodo population's behavioral monitoring's activity pattern from the previous night's passive acoustic recording, and the aquaculture management layer's production schedule notification of which gallery zones are in active harvest drone operation and which are in the quiescent post-harvest period when the fish population's behavior is most undisturbed. The guide reads all 4 inputs and selects the route that presents the formation's best current offer to that morning's safari group. A morning when the halocline has risen to 20 meters, when the Bodo population's overnight acoustic record shows the highest activity concentration in the mid-column zone near the largest aquaculture gallery section, when the synthetic reef succession model has just flagged the completion of a full succession cycle in the zone adjacent to the Intersynody Connection's freshwater zone entry, and when the harvest drone operation is scheduled for the afternoon rather than the morning, this morning's route is not the same as yesterday morning's route. It is the route that the formation's current conditions have specified. This route variability is the safari's primary distinction from the cycle sub's standard transit. The cycle sub's route follows the guide rail's geometry through the crystal tube network's passage configuration, which does not change with the formation's biological and geological conditions. The safari route is selected daily from the crystal tube network's full route option set by a professional whose training qualifies them to read the formation's current offer and match it to the safari group's experiential objectives. The Terraform Operator Guide is not a safari guide in the surface world's ecotourism sense, a naturalist whose knowledge is biological and whose role is primarily to identify and explain the biological community's species and behaviors. The Terraform Operator Guide is the installation's civil service professional whose formation monitoring training, ecological succession management expertise, and deep familiarity with the specific cenote's geological and biological character qualifies them to explain not just what the safari group is seeing but what the formation is doing, why the halocline is at today's depth, how the synthetic reef succession stage visible through this section's tube wall relates to the cleaning cycles. Most recent frequency, what the Bodo's proximity to the aquaculture gallery suggests about the morning's prey distribution model, why this specific passage section's tube wall shows a slightly different fouling character than the adjacent section and what the difference reveals about the underground river's local flow velocity at this depth. The guide explains the formation as a living system whose current state is the expression of the geological, hydrological, biological, and management processes that have been operating at this specific location for 66 million years and for the installation's operating period. Not as a collection of interesting natural history facts. As the operating output of a system that the guide monitors professionally and that the safari group is visiting at a specific moment in the system's continuous operation. The Transit Pod. The standard safari transit pod carries 8 participants and 1 guide in a configuration that the Geological Survey's cenote cross-section data specifies as compatible with the crystal tube network's interior diameter at the freshwater zone's standard passages, for rows of 2 seats each, the guide's position at the forward end with the route management interface, the transparent hull wrapping the full perimeter of the passenger compartment at the equivalent of window height for all seated positions. The seat arrangement prioritizes the hull's visual access. The seats face outward, portside seats face port, starboard seats face starboard, with each seat's occupant looking directly at the hull surface at the distance that the seat's position within the pod's width produces. The hull at each seat position is the seat's visual environment. The formation outside the hull is the seat's view. The separation between seats on opposite sides of the pod is the pod's interior width, approximately 1 meter at the aisle between facing seats, which is the maximum interior width the crystal tube's diameter and the hull material's minimum structural thickness allow. At 1 meter of separation, the participants facing port and the participants facing starboard are within social conversation distance of each other, looking at opposite walls of the same crystal tube section simultaneously. The participant on the port side watching the Bodos approach from the left sees the participant facing them watching the same Bodo from the right. The shared observation of the same biological event from 2 perspectives simultaneously is a social experience that the cycle sub's 2-person hull cannot produce. The safari pod's 8 participants observe the formation as a group, each from their own position. And the social amplification of shared observation intensifies the experience's emotional register in a way that the solitary observation of the cycle sub cannot. The group observation's social dimension is not incidental to the safari's design. The surface world's experience of extraordinary natural events, the whale breach, the elephant herds crossing, the predator's pursuit, is consistently described as more intense when shared than when witnessed alone. The intensity amplification from shared observation is a well-documented psychological phenomenon that the safari experience's design exploits. The guide's verbal narration provides the interpretive framework, the participants' shared visual field provides the common observational reference, and the spontaneous social responses, the sharp intake of breath when the boto appears at hull distance, the murmur of recognition when the guide identifies the harvest drone's return route, the collective silence when the halocline's optical dissolution presents itself in the full width of the pod's portside hull, produce the emotional resonance that transforms an interesting observation into a memorable experience. The guide's narration is the experience's intellectual layer. The group's shared response is the experience's emotional layer. The formation's current behavior is the experience's content. The pod's transparent hull at every seat is the experience's visual medium. The route through the crystal tube network is the experience's sequence. All 5 layers are simultaneously present in a safari session that is working as designed. A session where one layer is missing is a session the guide identifies and addresses. A group that is individually absorbed in their own observation and not sharing response cues is a group whose emotional layer the guide must activate through direct conversational invitation, asking a participant what they are currently observing, what they notice about the formation's color at this depth, whether the thermal change they may be feeling through the hull's material corresponds to the halocline's acoustic signature the guide is indicating on the route management interface's display. The guide's conversational activation of individual observation into shared observation is the social facilitation skill that the Terraform Operator's Guide training develops alongside the ecological expertise. The route sequence. The underground safari route sequence is a narrative arc, not a random collection of interesting sites, but a sequence whose order builds the participants' understanding of the formation's organization from the familiar to the alien, from the surface tier's orientation moment to the deep column zone's geological time encounter, with the halocline's optical dissolution as the arc's emotional pivot and the aquaculture city's trophic complexity as the arc's intellectual resolution. The sequence begins at the surface tier. The participants enter the transit pod at the orientation hub's docking port, in the atmospheric gallery where the coordinating system's display panels have provided the geological and biological briefing that the Terraform Operator Guide supplements with the current morning's conditions report. The pod departs from the orientation hub and the guide's first narration is the transition from the atmospheric space to the crystal tube's interior, the moment when the hub's full illumination gallery transitions to the crystal tube's light relay illumination and the pod's hull becomes the visual boundary between the participant's atmospheric position and the formation's aquatic environment. This transition is the safari's first reveal, the synthetic reef's mid-succession community on the tube wall at surface tier depth, illuminated by the light relay at the color temperature and intensity the coordinating system's biological management layer has optimized for the current primary producer composition. The guide's narration at this point identifies the community, names the functional groups visible through the hull, explains the mid-succession stage's position in the cycling process the Ancistrus cleaning maintains, notes the specific indication in this section's tube wall that the most recent cleaning cycle was recent enough that the pioneer recolonization is still at the stage before the mid-succession grazer community has fully established. The participants are looking at the wall. The guide is reading it. The guide's reading converts the participant's observation of a textured surface into an ecological interpretation that the wall's specific texture is communicating. The descent through the freshwater column continues the arc. The light relay's color temperature shifts as the depth increases and the surface daylight contribution decreases. The pod's hull thermal transfer begins to register as a slight temperature difference in the participants' hands if they are resting them against the hull material. The biological community's composition on the tube wall changes character as the depth decreases the light availability and the temperature drops toward the halocline. The guide narrates the changes, identifies the depth zone transition by the community composition shift, explains the temperature gradient's ecological significance for the species distribution, notes the current halocline's depth from the morning's sensor reading and how it compares to yesterday's and last month's and the seasonal maximum. The aquaculture gallery pass is the arc's sensory peak, the suspended mesh cylinders of the prawn production zone, the bioreactor column's blue-green luminosity against the light relay's transmitted beam, the freshwater lobster pen's artificial reef structure visible through the mesh in the mid-column zone's lower depth band, the harvest drone returning from a collection run in the opposite lane. The guide's narration at the aquaculture gallery section identifies the trophic logic, which species is producing what, how the waste output of the fish population above connects to the prawn population below, how the bioreactor column's oxygen production supplements the dissolved oxygen that the fish population's respiration depletes at peak production density. The participants are inside the food system. The guide is explaining the food system from inside it. The halocline crossing is the arc's pivot. The guide marks it, not dramatically, not with the performative elevation of the ecotours, and now, ladies and gentlemen, this is a terraform operator, whose professional relationship to the halocline is the daily monitoring reviews halocline depth measurement and the structural management protocol's zone boundary specification. The guide marks it as a formation scientist marks a boundary, with precision about what the boundary is, why it exists, what the two water masses are that it separates, and what the specific visual phenomenon the participants are now experiencing, the optical dissolution, the loss of visual sharpness in the formation outside the hull, the gelatinous shimmer in the intermediate distance, is physically produced by. The guide explains the halocline's physics at the moment the participants are experiencing the physics. Not before, the explanation before the experience produces a concept without an anchor in sensory reality. Not after, the explanation after the experience has passed cannot recover the sensory immediacy. The explanation during the experience anchors the sensory reality in the understanding that makes it more than an unusual visual effect. The participants know what they are looking at while they are looking at it. The knowledge adds a layer to the experience that the visual spectacle alone does not provide. The BOTO encounter in safari context. The BOTO encounter in the safari context is fundamentally different from the scavenger encounter, and the difference reveals something about the relationship between the observer's position and the quality of ecological knowledge the observation produces. The scavenger participant encounters the BOTO at close range in three-dimensional space, with the participant's body in the same water column as the BOTO, the alone visor between the participant's visual field and the BOTO's physical reality. The scavenger encounter is a meeting, two organisms in the same spatial environment, one choosing to approach and one choosing to hold position, the encounter's character determined by the BOTO's individual behavioral response to the participant's presence. The safari pod's BOTO encounter is an observation, the BOTO at hull distance from the pod, visible through the hull at the angle and illumination the guide rail's current position and the light relay's current intensity provide, its behavior undisturbed by the pod's presence in a way the scavenger's presence cannot fully achieve because the scavenger's body is in the water column and the BOTO's echolocation detects the scavenger's presence as a solid object in the BOTO's acoustic environment, while the pod's crystal tube section is already in the BOTO's acoustic environment as the tube wall that the BOTO maps every time it transits this passage section. The safari observation produces knowledge that the scavenger encounter cannot, the BOTO's undisturbed behavior at tube wall distance, the behavior the BOTO exhibits when nothing unusual is present in its environment, the baseline behavioral ecology that the behavioral monitoring research uses as the reference state against which scavenger encounters, intersynody transits, and harvest drone activity are assessed for behavioral impact. The safari pod at guide rail speed through a passage section the BOTO regularly transits is not a disruption to the BOTO's behavioral baseline. It is the BOTO's baseline, with the safari pod's occupants watching from inside the pod's atmospheric enclosure as the BOTO transits the same passage on the same schedule it transited before the crystal tube was installed, because the crystal tube's presence in the passage is now part of what the BOTO's echolocation maps as the passage's normal geometry. The guide identifies this for the participants. The BOTO's indifference to the pod is not the BOTO's unawareness of the pod. The BOTO knows the pod is there. The echolocation returns from the pod's polycarbonate gradient hull are in the BOTO's acoustic model of this passage section's geometry. The BOTO's indifference is the BOTO's assessment that the pod is not prey, not threat, not territory competitor, and not a behavioral novelty that warrants investigation at this moment, because the BOTO has assessed pods in this passage before and the assessment was the same. The BOTO is indifferent to the pod as the BOTO is indifferent to the crystal tube wall. The object is in the environment is known, the object is not interesting. This indifference is the formation's acceptance made legible in the BOTO's behavioral ecology. The BOTO is not ignoring the civilization. The BOTO has incorporated the civilization into its model of the cenote's geometry and determined that the civilization is not relevant to the BOTO's current behavioral priorities. The civilization and the BOTO are sharing the passage. The sharing is real. The BOTO knows the civilization is there and is not disturbed by it. This is the knowledge the safari produces about the BOTO that the scavenger cannot, not the encounter's intensity, not the approach's intimacy, not the individual BOTO's curiosity about the scavenger participant. The knowledge of what it means for the BOTO to have incorporated the installation into its normal behavioral landscape, to transit the passage with the crystal tube as part of the passage geometry, with the safari pod as part of the passage's acoustic and visual character, as unremarkable to the BOTO's daily behavioral priorities as the limestone wall and the halocline boundary and the aquaculture gallery's mesh cage surfaces. The BOTO is at home. The safari is watching the BOTO at home. The home is the formation. The formation is the civilization's habitat. The BOTO's comfort in the formation that the civilization inhabits is evidence that the civilization's presence has not made the formation less inhabitable for the BOTO, that the aquaforming doctrine's implementation has produced a civilization whose presence the formation's apex freshwater predator has assessed as compatible with continued normal habitation. This evidence is not in the bloodwork data or the acoustic monitoring record or the genetic census's population statistics. It is in the Boto's behavioral indifference to the transit pod in a passage the Boto has been transiting since before the crystal tube was installed, now transiting with the crystal tube installed, exhibiting the same behavioral indifference to the transit pod that it exhibits to the crystal tube wall and the anchor brackets and the light relays illumination cone. The Boto does not distinguish between the formation's natural geometry and the civilization's installed geometry in the passage. The civilization's geometry is now part of the formation's geometry. The Boto's behavioral assessment is complete. The guide explains this. The participants understand it. The Boto continues its transit. The geological narrative. The underground safari's geological narrative runs parallel to the biological narrative, not as a separate track that the guide delivers between biological observations, but as the explanation of why the biological observations are where and what they are. The formation's geological structure determines where each biological observation is possible. The halocline is where the freshwater and saltwater meet, and the freshwater meets the saltwater where the cenote's dissolution geology connected the surface recharge zone to the Caribbean's hydraulic gradient through a specific fracture network geometry that the Chicxulub impact produced 66 million years ago. The Boto is in the freshwater zone because the halocline is a biological lethal limit the Boto cannot cross, and the halocline is where it is because the geological gradient produced it there. The aquaculture gallery is in the mid-column zone because the species assigned to the mid-column zone's depth range require the conditions that depth range provides, and those conditions are determined by the dissolution geology's depth-dependent chemistry and the cenote opening's light column geometry. The biological observations are the surface expression of the geological structure. The guide narrates the surface expression while explaining the geological structure. The participants observe the biology while understanding the geology that produced the conditions the biology inhabits. This double-register narration, the biological observation and the geological explanation simultaneously, is the underground safari's intellectual achievement over the CycleSub's independent transit. The CycleSub's participants observe the formation and accumulate their own understanding from direct observation. The safari's participants observe the formation with the terraform operator's geological and biological expertise as a simultaneous second layer of interpretation. The expert's interpretation does not replace the participant's direct observation. It enriches the direct observation with the understanding that direct observation alone cannot produce, the geological history that produced the conditions, the ecological processes that produced the community, the management decisions that maintain the conditions within the range the community requires. The guide's narration is not a lecture. It is a conversation between the participant's direct observation and the guide's expertise, each participant's observation producing a question or a comment that the guide's expertise addresses, the guide's explanation producing a new observation in the participant's attention that the guide's next point will address. The route through the formation is the conversation's medium. The formation is the conversation's subject. The transit duration is the conversation's time. A well-guided safari's participants arrive at the return docking port having had a conversation about the cenote that they could not have had without the guide's expertise and that the guide could not have had without the participants' fresh observation of what the formation is currently presenting. The expertise and the observation are both necessary. The safari produces knowledge at the intersection. Augmented reality as optional layer. The coordinating system's Safari management layer offers an optional augmented reality overlay for participants who request it, a lightweight transparent display panel fitted inside the transit pod's hull section at each seat position, displaying the coordinating system's real-time interpretation of what the hull's optical sensors are detecting in the formation outside the pod's current position. The AR overlay is not the Safari's primary information layer. The guide's narration is the primary information layer, and the AR overlay is explicitly secondary, available for participants who want the coordinating system's quantitative data alongside the guide's qualitative interpretation, or who want to explore the biological census data for a specific species visible through the hull at the current moment rather than waiting for the guide's narration to reach that species in the route sequence. The AR overlay's content is limited by a deliberate design decision. It displays what the coordinating system can confirm rather than everything the coordinating system knows. At any position in the Safari route, the coordinating system's sensors are producing data about the biological community's composition at the current hull position, the water chemistry at the current depth, the halocline's current depth relative to the pod's position, the synthetic reef's current optical transmission coefficient at the current tube section, and the acoustic signature from the surrounding passage network at the current position. This is substantial data. The AR overlay displays a curated subset, the species identification for the biological organisms the hull's optical sensors can resolve at the current position's illumination level, the current depth in meters, and a simplified halocline indicator showing the pod's current depth relative to the halocline boundary. The curation is intentional. The AR overlay that displays every data parameter the coordinating system is collecting would produce a visual field saturated with data that the participant must process simultaneously with the direct visual observation of the formation and the guide's narration. The data saturation would reduce the direct observation's quality. The attention directed to the data display is attention removed from the formation itself. The overlay's curation maintains the direct observation as the primary experience and adds the data as a supplementary layer rather than replacing the observation with data. The participants who request the AR overlay are typically the participants whose prior knowledge of cave biology or geological systems gives them the context to use the species identification and depth data productively, to connect the coordinating system's data to their existing knowledge base and produce richer interpretation of the direct observation than the direct observation alone provides. The participants without that prior knowledge benefit more from the guide's narration than from the data overlay, because the guide's narration provides the interpretive context that makes the data meaningful. The AR overlay is available to all participants. Its use is self-selected. The participants who find it valuable use it. The participants who find it distracting can remove the display panel from their hull position and rely on the guide's narration. The overlay is infrastructure for the participants who need it and transparent to the participants who do not. The Safari experience does not require the overlay to be complete. The overlay supplements the experience for participants whose knowledge base benefits from the supplementation. The guide's ecological responsibility. The Terraform Operator Guide's role in the Safari carries an ecological responsibility that extends beyond the participant experience's quality. The guide's route selection, the guide's narration of the formation's current conditions, and the guide's behavioral management of the participant group's responses to biological community encounters all produce effects on the formation's biological community that the coordinating system's biological monitoring tracks as ecological impact indicators. The ecological impact indicators for the Safari program are assessed at the annual biological management review alongside the indicators for the scavenger program, the maintenance logistics, and the aquaculture operations. The review evaluates whether the Safari pod's transit frequency through specific passage sections is producing measurable changes in the synthetic reef succession trajectory at those sections relative to the succession model's prediction, whether the Bodo population's behavioral distribution is changing in response to the Safari route's frequency through specific passage zones, whether the cave fish community species composition and abundance at the Safari route's observation points is diverging from the biological census's baseline for those points. The guide's behavioral management of the participant group is the primary ecological impact control mechanism, a participant group that responds to a biological community encounter by attempting to photograph through the hull at close contact with the hull surface, pressing the camera lens against the hull material to reduce reflections, produces repeated hull surface contact events that the Ancistrus vitreous colony's cleaning schedule must accommodate. A participant group that speaks at elevated volume during a Bodo encounter produces acoustic energy transmitted through the hull that the Bodo's echolocation detects as atypical and that the behavioral monitoring has identified as associated with a reduced approach probability in subsequent encounters. A participant group that requests repeated slow passes through the aquaculture gallery section to observe the harvest drone produces transit repetition at the aquaculture gallery section that the coordinating system's production management schedules around but that the fish population's behavioral indicators show as mildly elevated activity, a disturbance signal below the threshold of welfare concern but above the behavioral baseline. The guide manages all three through the pre-session briefing and the real-time behavioral management during the transit. The briefing establishes the protocol for hull contact and voice volume and request accommodation, and the real-time management redirects participant behaviors that the guide's professional observation identifies as approaching the ecological impact threshold. The redirection is not punitive. The participants have not done something wrong. They are people in an extraordinary environment responding to an extraordinary experience with the behaviors that the experience spontaneously produces. The guide's management converts spontaneous responses that would produce ecological impact into alternative responses that produce the same emotional and experiential outcome with less ecological impact. The guide's ecological management skill is the aspect of the Terraform Operator Guide training that is most specific to the Safari context and least addressed by the formation monitoring and ecological succession management training that the certification program primarily develops. The guide training's Safari-specific module addresses behavioral management through simulated participant group interactions, the training equivalent of the Scavenger training's visual behavioral indicator library, but for the guide side of the participant formation interaction rather than the participant's side. The ecological responsibility that the guide carries is the Safari program's contribution to the founding charter's visitor experience philosophy. The visitor experience that is conducted with full ecological responsibility produces encounters that participants can sustain without accumulating the ecological impact that would eventually degrade the formation's condition and therefore degrade the encounter itself. The ecological responsibility is not a constraint on the visitor experience. It is the condition under which the visitor experience remains possible at the quality that makes it worth having. Sleeping inside the aquifer. The Safari standard configuration is a transit experience, a single pod transit through the freshwater zone's crystal tube network, returning to the orientation hub at the session's conclusion. The extended configuration is the overnight safari, a transit that concludes at a waypoint accommodation rather than at the orientation hub, and that resumes from the waypoint accommodation the following morning. The waypoint accommodation is the installation's most intimate residential offering, a small suite, 2 to 4 participants maximum, embedded in the crystal tube network at a junction node that the route configuration places at the midpoint of the 2-day safari's first day transit. The suite is not a hotel room with a cenote view. It is a room inside the cenote, a crystal tube section of larger cross-section than the transit passages, fitted with sleeping accommodation and a small dining area, whose exterior hull is the same gradient laminate material as the transit pod's hull and the crystal tube network standard sections. The room's hull is the cenote. The cenote is what the room sees. The waypoint accommodation's design is the CycleSub's design philosophy applied at the residential scale, the transparent hull because the aquifer is worth seeing, the room's position in the crystal tube network because the aquifer's continuous presence is the residential experience's premise rather than a view from a window. The room is inside the aquifer structure. The aquifer is visible from every point in the room through the hull's full transparency. At night, inside the waypoint accommodation with the light relay's illumination reduced to the biological management protocol's biological minimum, the light intensity that maintains the photosynthetic primary production at the minimum necessary to prevent community regression while minimizing the light pollution that the cave fish community's circadian biology requires darkness to express. The suite's hull is the transparent boundary between the atmospheric interior and the cenotes. Nocturnal aquatic environment. The nocturnal aquatic environment is different from the daytime aquatic environment in ways that the safari's standard daytime transit cannot reveal. The cave fish community's circadian activity peaks in the low illumination hours. The bioluminescent signals of the lithocrustacean colony's resting phase coordination are visible through the hull at the light intensity levels the suite's interior illumination produces when the interior lights are extinguished, and the boto population's acoustic activity in the low illumination hours, the social vocalizations and the echolocation activity of individuals that are actively hunting in the aquaculture gallery's vicinity, is transmitted through the hull material as vibration that the participant inside the suite can feel through the contact of their body with the suite's sleeping surface. The participant who spends a night in the waypoint accommodation experiences something that no single session safari produces, the formation across its full daily cycle, from the morning's activity peak to the midday's thermal stratification maximum to the evening's biological community transition to the nocturnal period's altered biological character. The formation across its daily cycle is not just more of the same formation. It is a different formation, the same space expressing different biological and physical states as the light cycle, the temperature cycle, and the biological community's circadian rhythms express themselves across the full 24-hour period. The overnight experience is not offered to all safari participants. It is offered to longevity program enrolled participants whose blood work and medical monitoring have been evaluated by the coordinating system's medical assessment layer as showing potential benefit from the extended ambient pressure exposure that the waypoint accommodation's depth position provides across the overnight stay. The accommodation's depth places it in the therapeutic pressure range for the enrolled participant's protocol, and the overnight stay's continuous pressure exposure adds to the cumulative therapeutic exposure that the longevity program's gallery enrollment provides. The overnight safari is an extension of the therapeutic protocol by other means. The pressure is the same, the nitrox atmosphere is the same, the body's response is the same, and the experience is the one that the safari produces instead of the gallery's rest mode. The two experiences serve the same therapeutic function at the medical level. The safari's accommodation version serves it in a context that the gallery cannot provide, surrounded by the formation's full spatial volume through the hull's transparency, with the formation's nocturnal biological character present in the acoustic and visual field throughout the sleeping period, with the morning's activity transition as the natural waking event rather than the gallery's scheduled atmospheric management cycle's air replacement signal. The participant who wakes in the waypoint accommodation to the morning's light relay activation, the coordinating system's biological management layer bringing the relay to daytime intensity on the dawn schedule that the formation's biological community circadian protocols specify, wakes inside the aquifer as the aquifer transitions from night to day. The transition is not the sun rising over a landscape. It is the cenote's biological community transitioning between its nocturnal and diurnal behavioral states as the light relay's photosynthetically active output crosses the threshold that the biological monitoring identifies as the circadian trigger for the cave fish community's behavioral transition and the synthetic reef's primary production community's photosynthetic activation. The waking moment is the formation's morning. The participant experiences it from inside the formation. The safari as civilizational argument. The underground safari is the most complete single expression of the visitor experience's civilizational argument because it combines all three registers that the argument requires simultaneously. The first register is the encounter, the direct sensory engagement with the formation's biological and geological character that the safari's transit through the crystal tube network's freshwater zone produces. The encounter requires the formation's actual presence, the transparent hull's visual access, the route's curation for the current biological conditions, and the transit pace that makes the formation legible rather than spectacular. The second register is the understanding, the interpretive framework the Terraform Operator Guide provides that converts the encounter's sensory richness into knowledge about the formation's organization, history, and ongoing operation. The understanding requires the guide's expertise, the narration's timing with the encounter's visual events, and the participant's intellectual engagement with the interpretation the narration offers. The third register is the implication, the meaning the encounter and the understanding together produce about the civilization that made this encounter possible by choosing to inhabit the formation rather than exploit it. The implication requires that the encounter and the understanding have been rich enough that their synthesis produces the insight that the civilization's choice is visible in the formation's condition, that the Bodo's behavioral indifference to the transit pod is evidence of the civilization's ecological discipline, that the synthetic reef's mid-succession community on the tube wall is evidence of the cleaning management's accuracy, that the halocline's current depth relative to yesterday's depth is evidence of the regional water stewardship's monitoring program's data continuity, that the aquaculture gallery's production visible through the hull is evidence of the closed-loop economics that the founding charter's sans a priori design philosophy produced. The three registers are all present in a safari session when the guide is excellent, the formation's conditions are at their current best offer, and the participant group's prior knowledge and experiential engagement allow the encounter and the understanding to produce the implication. They are not all present in every session. The encounter is always present, the formation is always the formation, even on mornings when the Boto is elsewhere and the halocline is below the route's maximum depth and the harvest drones are active in the gallery sections the route passes through. The understanding depends on the guide's narration finding the current offer strongest element and building the understanding around it. The implication emerges when the encounter and the understanding have been rich enough. The safari session where all three registers are active is not a spectacular safari. It is not the session where the Boto appeared at hull distance for 23 seconds or the session where the halocline's dissolution effect was at its seasonal maximum depth and most visually intense. Those sessions produce the first register at maximum intensity. The safari session where all three registers are active is the session where the participant understood why the Boto appeared at hull distance and what the Boto's appearance indicates about the civilization's ecological discipline, and understood why the halocline's dissolution effect is most intense at the seasonal depth where they are observing it and what the halocline's depth indicates about the regional water stewardship's seasonal management performance. The implication is what the formation's condition tells the participant about the civilization that manages the formation. The formation cannot be spectacular without the civilization having made it spectacular through careful management. The botanical garden's beauty is the horticulturalist's achievement. The cenote's beauty is, in a more complex sense, because the cenote's beauty existed before the civilization arrived and the civilization's achievement is maintaining it, the ecological management's achievement. The management that maintains the Boto's behavioral baseline, the synthetic reef succession cycle, the aquaculture gallery's species composition, the halocline's hydrological depth, and the formation's geological integrity is not visible directly. It is visible in what the formation looks like when the management has been done correctly. The safari is the argument that the management has been done correctly. The formation is the evidence. The guide is the witness. The participant is the jury. A civilization that invites scrutiny of the evidence for its ecological discipline is a civilization that is confident of the evidence. The underground safari is that invitation. The underground safari and the surface world. Every safari participant who returns to the surface world carries the safari's three registers with them, the encounter's sensory memory, the understanding's interpretive framework, and the implication's conclusion about what a civilization that inhabits a formation rather than exploiting it looks like from inside. The surface world has no direct equivalent of this experience. The surface world's geological formations are visible from above, from the side, from the margins. The cenote is visible from inside, from the inhabited volume that the crystal tube network has made accessible to human occupancy while maintaining the formation's conditions within the biological management protocol's conservation standards. The surface world's exceptional natural environments are accessible through tourism that preserves them by limiting access, interpreting them through signage, and managing the visitor's encounter with them through the barriers, the viewing platform, the designated trail, the restricted zone, that prevent the visitor from damaging what the visit is intended to reveal. Pipe Dream's approach inverts this. The formation is accessible from inside because the installation that makes interior access possible was built in ways that the formation's biological community has incorporated into its normal environmental landscape. The formation is preserved not by limiting access but by building the access infrastructure within the formation's ecological tolerance in the same process by which the civilization built its habitation infrastructure. The tourist infrastructure and the habitation infrastructure are the same infrastructure. The tourist experience is the habitation experience offered at a different enrollment duration. The participant who has experienced the formation from inside, who knows the cenote's biological and geological organization from the safari's three-register encounter, carries that knowledge back to the surface world as a direct experiential reference. Not a concept. Not a description. A memory of specific encounters with specific formation conditions at specific moments in the formation's daily and seasonal cycle, interpreted by a professional whose expertise made the encounter legible beyond what direct observation alone produces. This knowledge changes what the participant is likely to say and do when decisions about geological formations, freshwater systems, and biological communities are being made in the surface world's political and economic contexts. Not because the safari taught a lesson, Because the safari produced an experience that the participants' subsequent reasoning references when ecological arguments are made in the surface world's debates. The civilization that wants the surface world to understand what aquaforming produces does not publish manifestos or send delegations. It invites people inside and shows them what the formation looks like when the civilization inhabits it correctly. The underground safari is the invitation. The formation is the argument. The participant's memory of the encounter is the argument's delivery mechanism. A civilization that trusts its formation to make its argument for it is a civilization that is confident in what the formation says. The formation says, I have been here 66 million years, I have accepted the civilization's presence, I am still here, and here is what I look like when I am cared for. The safari is the hearing. The participant is the listener. The formation is the speaker. Cross-references, Part 2, CH1, Cities Made of Light, Part 3, CH4, Underground Boulevards, Part 5, CH3, Pink Dolphins, Part 5, CH5, Synthetic Reefs, Part 5, CH6, Ecology as Infrastructure, Part 6, CH1, Pedal Submarines, Part 6, CH2, Scaphanders for Everyone, Part 6, CH4, Augmented Reality Beneath the Earth, Part 8, Section B, The Living Pantry, Part 11, CH2, The Nitrox Galleries. For Safari Transit Pod Specifications and Hull Optical Geometry Parameters, see Appendix D, Construction Operations Manual. For Terraform Operator Guide Certification Requirements and Safari-Specific Behavioral Management Training Module, see Appendix H, Governance Operations Manual. For Safari Ecological Impact Indicator Monitoring Protocol and Annual Biological Management Review Integration, see Appendix F, Biological Operations Manual. For Waypoint Accommodation Design Specification and Overnight Longevity Protocol Integration Parameters, see Appendix D, Construction Operations Manual. For AR Overlay Content Curation Specification and Display Panel Integration with Transit Pod Hull, see Appendix D, Construction Operations Manual. Pipe Dream. Part 6, The Visitor Experience. Chapter 4, Augmented Reality Beneath the Earth. Augmented reality has a definition problem. The surface world uses the term to describe a range of technologies from the trivial, the restaurant menu that animates when you point a phone at it, to the architecturally significant, the navigation overlay that replaces the need to read a map with a directional arrow projected into the visual field. What the range shares is the premise that the visual field the user already has is insufficient for the task, and that adding digital information to that visual field improves the task's outcome. The augmentation supplements. The supplement addresses a deficiency. The deficiency is in the natural visual field's ability to provide the information the task requires. In the Cenotes crystal tube network, the natural visual field has no deficiency. The formation is there. The biological community is there. The geological structure is there. The halocline is doing its optical dissolution. The boto is navigating the passage geometry that its echolocation maps. The synthetic reef succession community is expressing the succession stage that the last ancestors vitreous cleaning cycle and the light relays photosynthetically active output have produced. All of this is in the visual field. All of this is legible to the unaided human visual system at the distances the crystal tube's passage geometry creates. The visual field is not insufficient. What the visual field does not provide is the knowledge that makes the formation's current expression legible at the depth the expert's understanding achieves. The participant who sees the synthetic reef surface texture without the ecological framework to interpret it sees a textured surface. The participant who sees the same surface texture with the framework that identifies the texture's succession stage, the cleaning cycle's recent timing, and the primary producer community's current dominant species sees an ecological state, a specific moment in the biological system's continuous operation, with implications for the management protocol's next intervention timing and for the food web's current productivity level. The visual field is the same. The knowledge that makes the visual field legible differs by the quality of the interpretive framework the observer brings to it. Augmented reality in Pipe Dream's visitor experience is the technology that provides the interpretive framework to observers who do not have it, that makes the formation's current expression legible to the visitor whose prior knowledge cannot achieve the expert's interpretation from direct observation alone. Not a supplement to an insufficient visual field. A translation layer for a visual field that contains more information than the unaided observer can read. The design philosophy distinction matters because it determines what the AR system is for. A supplement to an insufficient visual field competes with the visual field. The more AR content is added, the less of the natural visual field the observer attends to. A translation layer for an information-rich visual field serves the visual field. The more accurately it translates, the more of the visual field's information the observer can access. The supplement replaces attention. The translation redirects attention toward what the visual field already contains. Pipe Dream's AR implementation was specified from this distinction. The AR layer must enhance the observer's access to the visual field's existing information content without competing with the visual field for the observer's attention. Any AR element that requires the observer to look at the AR layer rather than at the formation is an AR element that has crossed from translation to supplement. The specifications test for each AR element is, does this element direct the observer's attention toward the formation or away from it? Elements that pass the test are in the system. Elements that fail are not, regardless of how technically interesting they are or how much information they carry. The display substrate. The AR display cannot be a screen that the observer looks at. A screen imposes a boundary, the frame's edge, the backlight's reflection on the glass surface, the focal distance adjustment from the screen to the background, that the observer's visual system registers as a transition between the screen's content and the natural visual field behind it. The transition is the supplement's fingerprint. The screen is separate from the visual field, present as an addition to the visual field, competing for the observer's focal attention. The AR display in Pipedream's system is the visual field's interface material itself. In the Scaphander, the Alone Dome visor. In the Transit pod, the gradient laminate hull at each seat position. In the Safari pod, the same hull material with the display substrate integrated into the outer glass ceramic layer's interface rather than added as a separate layer. The display substrate is a metamaterial coating applied to the visual field's interface material during fabrication, a precisely controlled nanostructured layer at the interface between the glass ceramic outer layer and the gradient laminate's transition zone, whose optical properties are normally invisible. The coating's refractive index matches the glass ceramic layer's refractive index sufficiently that no optical discontinuity is perceptible at the coating's boundaries under normal cenote illumination, but which can be locally activated by the display driver's infrared control signal to produce a refractive index shift at the activation zone's boundaries that the human visual system perceives as a faint luminous line or text at the activation zone's position. The activated display is not a projection. It is a refractive index modulation in the interface material itself, a change in the material's optical properties at a specific location, producing the visual effect of a faint line or text without any added light source, without any screen in the observer's focal path, without any frame boundary between the activated zone's content and the natural visual field surrounding it. The faint luminous line or text the modulation produces is perceptible when the observer's attention is directed to it, when the observer is looking at the interface material at the distance and angle that the activation zone's refractive index shift is optimized for, and nearly imperceptible when the observer's attention is directed through the interface material at the formation beyond. The AR content is in the peripheral visual field's background when the observer is attending to the formation, and in the central visual field's foreground when the observer is attending to the interface material's surface. This figure-ground relationship is the display substrate's critical optical property. The AR content is readable when sought and invisible when not sought. The observer who wants to read the AR content looks at the interface material's surface and reads the modulation's content in the focal plane that the interface material occupies. The observer who wants to see the formation looks through the interface material at the formation beyond, and the AR content recedes to below the threshold of conscious visual perception. The display driver achieves this figure-ground relationship through the modulation's intensity calibration. The refractive index shift's magnitude at each activation zone is calibrated to the minimum modulation that produces readability at the interface material's focal distance under the current ambient illumination conditions. At that minimum magnitude, the modulation is perceptible to an observer focusing on the interface material and imperceptible to an observer focusing through it. The calibration is dynamic. The coordinating system's AR management layer adjusts the modulation intensity in real time as the ambient illumination changes with depth, passage geometry, and light relay output. The display substrate's fabrication is the Scaphander and hull material's most technically demanding manufacturing step. The nanostructured coating spatial resolution must be sufficient to produce readable text at the interface material's optical distance from the observer's eyes, which at the Scaphander visor's geometry is approximately 30 centimeters. Text readability at 30 centimeters requires character heights of approximately 2 to 3 millimeters, requiring the nanostructured coating's activation zone resolution to be finer than 2 millimeters. The current fabrication process achieves 1.5 mm resolution, providing the 30% margin above the readability threshold that the system specification requires. What the AR system displays. The AR system's content is the coordinating system's real-time interpretation of the formation's current state at the observer's current position. Not the coordinating system's full data output. The data stream the coordinating system maintains from every sensor in the installation at every update interval would overwhelm any display system, and its selection for any given observer's position would require a content curation algorithm more sophisticated than the display substrate's current implementation. The AR system displays a curated subset of the coordinating system's current data, selected by the content curation protocol that the visitor experience philosophy's attention test specifies. The curated subset's content is organized in 3 tiers of visual prominence: the ambient tier, which is always present at the minimum display intensity and provides basic orientation data; the contextual tier, which activates when the observer's current position places them at a geological or biological boundary that the coordinating system's location tracking identifies; and the species identification tier, which activates when the observer's Scaphander visor's optical sensors resolve a biological organism to the resolution that the species identification algorithm can produce a competent identification. The ambient tier's always present content is the minimum that the visitor experience philosophy's attention test permits, current depth in meters, displayed at the interface material's lower right corner in a font size calibrated to readability at a single glance without requiring visual focus to be held, current time since departure from the last docking port, displayed at the lower left corner in the same format, and a single icon indicating whether the current tube section's crystal. Specification optical transmission is within specification, a clear circle when within specification, a faint yellow circle when approaching the threshold, a faint orange circle when the section has been flagged for next cycle priority cleaning. 3 data points, displayed in the peripheral visual field's lower boundary, requiring a brief glance to read and no sustained attention to monitor. The ambient tier is the AR system's safety infrastructure. The depth indicator is the scavenger participant's primary altitude reference, confirming throughout the dive that the participant has not descended below the protocol's maximum depth assignment. The time indicator is the rebreather's implicit warning system, not displaying the rebreather's remaining capacity directly but displaying the elapsed time that the participant's training protocol maps to the remaining capacity given the session's activity level. And the crystal specification indicator is the participant's ecological impact monitoring. The faint orange circle that appears when the section the participant is currently in has accumulated fouling above the standard cleaning interval's scheduled service is the AR system's communication that the participant's biological community observation at this position is observing a community at higher than optimal fouling density, not at the managed mid-succession community the standard protocol maintains. The contextual tier's boundary activated content is the system's most interpretively valuable layer and the layer that most directly serves the formation translation philosophy. When the coordinating system's location tracking places the observer within the halocline zone, the depth band where the halocline sensor network's salinity gradient registers the freshwater-saltwater boundary, the contextual display activates, overlaying the interface material's whole view with the current halocline-specific depth in meters, not the observation's depth, but the halocline boundary's depth below the cenote's water surface, the current halocline's depth deviation from the seasonal baseline, whether the halocline is above or below its standard position for this time of year by how many meters, and a simplified schematic of the halocline's current acoustic temperature profile, the temperature and salinity gradient's vertical structure at the current position, rendered as a simple curve that the observer can compare against the visual dissolution effect visible through the hull. The halocline contextual display is the AR system's most effective translation element. The observer experiencing the halocline's optical dissolution through the hull now has, in the peripheral visual field, the quantitative description of the physical conditions producing the optical phenomenon they are observing. The dissolution effect and the quantitative data are simultaneously present, the phenomenon visible through the interface material, the data at the interface material's surface. The observer does not need to look away from the phenomenon to read the data. The data and the phenomenon are co-present in the same glances field. When the coordinating system's location tracking places the observer adjacent to a passage section where the acoustic characterization data has identified an active geological feature, a dissolution void whose dimensions have changed measurably since the previous survey cycle, a limestone surface where the stewardship lithocrustacean colony's paste application is in progress, the contextual display identifies the feature and displays the coordinating system's current geological status, the void's current dimensions compared to the survey baseline, the paste application's current progress toward the treatment zone's consolidation target, the geological model's assessment of the feature's significance for the crystal tube network's structural integrity in the adjacent section. The geological contextual display is the AR system's most specific contribution to the visitor's understanding of the civilization's geological stewardship function. A participant who sees through the scavenger visor the stewardship lithocrustacean colony working the passage wall at a dissolution zone, who can see the organisms moving across the wall surface and the pale paste output on the limestone behind them, now has, simultaneously in the peripheral display, the geological context, how significant this dissolution zone is, how long the stewardship treatment is expected to take, what the geological model projects the treated zone's structural condition will be at the treatment's completion. The observation and the data together produce the understanding that neither alone produces. The species identification tier. The species identification tier is the AR system's most complex software component and its most immediately legible interface for participants without ecological expertise. The coordinating system's image recognition algorithms, trained on the biological monitoring network's full species identification library, analyze the visual feed from the scavenger visor's optical sensors or the transit pod's hull-mounted optical sensors in real time, identifying biological organisms in the visual field at the confidence level the resolution and illumination conditions allow. When the algorithm identifies an organism at or above the confidence threshold, 60% confidence that the organism in the visual field is the identified species, calibrated to produce false identification rates below the level that the Terraform operator guide's monitoring identifies as producing participant confusion, the species identification overlay activates at the organism's position in the visual field, a minimal icon indicating that the organism has been identified, in the Color assigned to the organism's functional group in the AR system's visual vocabulary, and a species name in the interface language the participant specified at registration. The species name in the participant's registration language is the AR system's most deliberate design decision and the one that most directly expresses the visitor experience philosophy's attention test. The species name in the participant's native language creates a linguistic anchor for the observation. The participant who sees the boto approaching and simultaneously sees boto or river dolphin or in the peripheral visual field has a word to attach to the encounter that the encounter's pre-session briefing has explained. The word does not replace the observation. It connects the observation to the existing knowledge structure the briefing created. The linguistic anchor is the translation layer's most basic function. The species name is the only text the identification tier displays at the first identification moment. No ecological description, no behavioral notes, no population status, no management protocol information. These are available on request through the interaction protocol that the participant can activate by a specific gaze direction that the visor's eye tracking interprets as a content request, but they do not appear automatically. The automatic display is the minimum that passes the attention test, a name in the peripheral field that confirms the identification and anchors it linguistically, available at a glance, not requiring sustained attention, not competing with the organism itself for the central visual field. The content on request interaction is the AR system's most sophisticated interface element. The participant who wants to know more about the identified organism looks at the identification icon at the organism's position in the visual field, a shift of gaze direction that the visor's eye tracking interprets as a dwell command, and the contextual content expands from the minimal icon to the full species information panel, occupying a larger section of the interface materials display area and providing the ecological and behavioral information the participant is requesting. The dwell command requires approximately 1 second of sustained gaze at the icon position, long enough to prevent accidental activation but short enough to feel responsive. The full species information panel's content is the curated subset of the coordinating system species records that the visitor experience philosophy's attention test permits for the information-rich context of an active encounter, species name, functional role in the freshwater zone's food web, current population status in the cenote, stable, monitored, or alert. The monitoring alert condition that the terraform operator's concurrent authority is required to address, and a single sentence of behavioral ecology specific to the current observed behavior. Not the species' full biological profile. The current encounter's biological context. The boto approaching at 3.5 meters with the echolocation active in the curiosity investigation pattern. The species information panel displays boto, Aenea geofrensis cenote variant, apex freshwater predator, population, stable, currently echolocating in social investigation mode, approach likely in 1 to 3 minutes at current trajectory. The panel displays what the participant's immediate encounter requires, derived from the behavioral monitoring's real-time data, not from a static species database entry. The behavioral ecology in the panel is the current behavioral ecology, not the species' general behavioral ecology. The panel's single sentence of behavioral ecology is the AR system's contribution to the real-time encounters management. The participant who knows approach likely in 1 to 3 minutes holds position rather than approaching toward the boto, allowing the boto's approach to proceed at the boto's behavioral pace. The behavioral prediction does not replace the approach protocol's scavenger management layer's proximity restriction. It adds the behavioral context that makes the protocol's effect comprehensible, the participant holding position because the restriction requires it, now understanding that the restriction is maintaining the conditions for the boto's approach prediction to be correct. AR and emergency conditions. The AR system's role shifts in emergency conditions from translation layer to navigation infrastructure. In the blackout protocol's power failure scenario, the AR system's standard display substrate is offline. The display driver that activates the metamaterial coating's refractive index modulations requires the scavenger's battery power or the transit pod's electromagnetic system power, and the blackout protocol's defining condition is the absence of battery or electromagnetic power. The emergency AR infrastructure is the strontium illuminate marker's luminescent emissions read by the scavenger visor's passive optical sensors. The passive optical sensors, solar cell technology, generating sufficient power from the bioluminescent output of the cave's natural biological community at the minimum illumination conditions present even in a complete system power failure, maintain operation in the blackout protocol condition. The passive sensors detect the strontium illuminate marker's glow along the guide rail's physical teeth. The detection is transmitted to the visor's emergency display system, a separate display circuit powered by the passive sensor's generation, not by the main battery, which activates a minimal overlay showing the detected marker's positions as a green line in the visual field. The emergency AR overlay is the most minimal display the system produces, a green line indicating the guide rail's direction, updated as the marker's positions change in the visor's sensor field as the participant moves along the rail in the mechanical drive mode. No species identification. No geological context. No species information panels. The green line and the direction it indicates. The navigation overlay the blackout protocol's training protocol prepares every participant to read. The emergency overlay's minimal content is not a limitation of the emergency display circuit's capability. It is a deliberate design decision. In an emergency condition where the participant is pedaling the cycle sub's flywheel through the darkness, monitoring the soda lime canister's CO2 indicator, and tracking the guide rail's physical teeth through the scaphandar visor, the additional cognitive load of species identification pop-ups and geological context panels is a hazard rather than an assistance. The emergency overlay displays what the emergency requires, where the rail is. Everything else can wait until the next docking station. The emergency overlay's design was validated against the participant experience monitoring data from the training protocol's blackout simulation sessions, the sessions where participants practice operating the emergency systems before any transit begins. The simulation's AR display configuration was compared across full content, reduced content, and green line-only configurations. The coordinating system's participant performance monitoring, measuring the time to reach the next simulated docking station from the simulated power failure event, under each AR configuration, showed that the green line-only configuration produced the fastest docking station reach times. More information in the emergency display produced slower navigation performance. The visual system's attentional resources directed toward processing the additional information are attentional resources not available for the navigation task the emergency requires. The emergency overlay is the navigation minimum. The navigation minimum is the emergency maximum. The geological timeline display. The geological timeline display is the AR system's most ambitious content element and the one that most directly addresses the visitor experience philosophy's deepest ambition, producing in the visitor the sense of geological time, the specific understanding that the cenote's current state is one frame in a 66 million year film, and that the specific geological and biological conditions present at the current moment are the products of a specific sequence of events across a timescale. That the human mind cannot intuitively grasp but that the AR system can make present in the visual field in a form the human visual system can process. The geological timeline display activates at specific passages in the safari route and specific locations along the scaphandar session's permitted dive zone, locations where the geological record in the visible limestone surface is sufficiently rich that the AR system's geological characterization data can support the timeline's content. The limestone speleothem formations visible through the hull, stalactites, stalagmites, flowstone deposits, are the display's visual anchors. Each formation visible through the hull has a growth record that the coordinating system's geological survey data has sampled and dated. The timeline display overlays the formation's visible surface with a simplified visual representation of the formation's growth history, the oldest datable material in the visible formation highlighted in a deep blue, younger deposits in successively lighter blues toward the present's warm white, with a scale at the interface material's right edge showing the color's correspondence to age in thousands of years. The stalactite that appears to be a uniform brown limestone column is revealed as a 7-color gradient in the AR overlay, oldest growth at the tip. The stalactite's oldest material is at the tip where growth began, the youngest is the most recently deposited layer at the outer surface, grading through the age spectrum to the youngest surface material. The visual impression the overlay produces is the visual language for geological time. The stalactite is not a geological curiosity of unknown age. It is a documented historical record whose current visible surface is this year's geological output and whose interior is 10,000 years of annual increments laid down at the cenote's specific rainfall and biological productivity conditions at each year of the record. The participant looking at the stalactite through the AR overlay is looking at 10,000 years of climate and biology compressed into a stone column 30 centimeters in diameter. The overlay shows them how many years of history the column contains. The geological timeline display does not make the observer feel geological time. It shows the observer what geological time produced. The distinction is precise. Feeling geological time would require experiencing 10,000 years. Seeing what 10,000 years produced requires looking at the stalactite's growth record displayed in the age color gradient. The display achieves the second in a single glance. The first is not achievable in a 40-minute dive. What the display achieves is that the participant who has seen the stalactite's age color gradient has a visual reference for the phrase 10,000 years that was not present in their visual memory before the dive. When a geological timescale is discussed in the surface world's political or environmental contexts, the participant who has seen the cenote's stalactite displayed in the geological timeline's color gradient has a visual anchor for the number. Not the experience of the time. The visual evidence of the time's product. The anchor is what changes the participant's relationship to geological timescale in subsequent encounters with geological arguments. The food web visualization. The food web visualization activates in the aquaculture gallery sections of the safari route, the passage sections where the transit pod or cycle sub passes through the living pantry corridor cenote's aquaculture galleries, where the production species in their cylindrical mesh cages and the harvest drone fleet in the designated lane are simultaneously visible through the hull at close range. The food web visualization does not describe the species in the aquaculture gallery. The species identification tier does that. The food web visualization describes the ecological relationships between the species, the trophic connections that the ecological management protocol has organized the gallery's species composition to exploit, and the nutrient flow paths that connect the gallery's biological production to the installation's other biological systems. The visualization is animated, the only animated content in the AR system, and the only content that is not present in the visual field's existing information but is added as new graphical content. The animation shows, as a flowing pattern over the production species positions in the visual field, the direction and relative rate of nutrient flow, from the spiruline bioreactor column to the prawn's cage through the feeding supplement pathway, from the prawn's cage to the fish's cage through the prey availability pathway, from the fish's metabolic waste to the synthetic reef's nitrogen cycling through the dissolved ammonia pathway, from the mussel's filter feeding to the sediment accumulation through the organic capture pathway. The flows are shown as translucent colored currents overlaid on the visible gallery, thin enough to allow the gallery's actual visual content to show through them, wide enough to be visually legible as the flow directions they represent. The color assignment is the AR system's ecological vocabulary: green for photosynthetic production flows, blue for water quality processing flows, amber for food chain flows, and gray for waste stream flows. The color vocabulary is introduced in the pre-session orientation and is consistent across every AR content element that uses flow representation. The animated food web over the aquaculture gallery is the AR system's most direct answer to the question that every participant asks when looking at the gallery from inside the transit pod: how does all of this work together? The answer is not in the species identification of each species individually. The individual species functions are separately legible from the species information panels. The answer is in the connections between species that the food web visualization makes visible as a simultaneous whole. The gallery is not a collection of independent production units. It is an ecological network whose connections produce the closed-loop efficiency that the installation's economics depend on. The food web visualization shows the connections at the moment the participant is looking at the gallery. The animation's pace is calibrated to the transit pod's transit speed through the gallery section. At the boulevard's operating speed through the gallery, the animation's flow rates are high enough to be perceptible in the time the gallery section occupies the visual field. At the pedaling mode's slower speed, the animation's flow rates are reduced to the pace that the longer visual field dwell time allows, slower flows that are more detailed in their representation of the specific pathway's rate relative to the others. The animation is not at a fixed pace. It is synchronized to the transit's pace so that the observer always has the time the current speed allows to read the animation. What AR cannot do. The AR system's design philosophy identifies what augmented reality is for by being equally specific about what it is not for. AR cannot produce the experience of encounter. The Bodo's approach to 2.4 meters through the alone visor is an encounter. The Bodo's image in an AR system species identification overlay is an identification. The identification is valuable, it anchors the encounter in the participant's linguistic and knowledge framework. But the AR system that substituted an AR rendering of a Bodo for an encounter with the actual Bodo would be producing the poorest possible version of what the cenote offers and calling it augmented reality. The surface world's immersive AR and VR industries have produced technically impressive renderings of natural environments that the rendering's audience can experience in the comfort of a room in a building in a city, without the expense or difficulty of traveling to the natural environment. These renderings serve genuine functions for education, access equity, and environmental awareness. They are not the same as the natural environment, and no technical advancement in rendering fidelity changes the relationship between the rendering and the original. Pipedream's AR system does not render the cenote. The cenote renders the cenote. The AR system adds the translation layer that makes the cenote's rendering legible to observers who do not have the expert's interpretive framework. The translation layer serves the original. It does not substitute for the original. The design constraint that follows from this: no AR element in the system represents anything that is not currently present in the visual field. The food web visualization's flows represent the actual trophic pathways of the actual species actually present in the gallery the transit pod is actually passing through at the current moment. The geological timeline's age color gradient represents the actual growth record of the actual stalactite the scavenger participant is actually hovering in front of at the current moment. The species identification overlay identifies the actual organism the participant's visor's optical sensors are actually resolving at the current depth zone's actual illumination level. AR that represents things not present in the visual field, historical reconstructions of the cenote's past states, predictive renderings of future states, comparative overlays showing what the cenote would look like under different management decisions, is educational content that belongs in the pre-session briefing, not in the dive's real-time AR layer. The real-time AR layer represents the real-time formation. The formation is what the participant came to encounter. The AR layer makes the encounter more legible. It does not replace the encounter with representations of what is not there. This constraint is not a limitation of the AR system's technical capability. The coordinating systems data archives contain the geological history reconstructions, the ecological succession models' future projections, and the counterfactual management scenario analyses that the surface world's environmental visualization platforms would deploy as immersive AR content. The constraint is the visitor experience philosophy's choice not to use them in the real-time dive context. The data is available. The philosophy determines the use. The AR system's relationship to memory. The AR system's content is real-time and ephemeral. The species identification that appeared at the current position disappears when the observer moves past the organism's position. The halocline contextual data that was present at the halocline zone's depth is absent at the freshwater zone's shallower depths. The geological timeline's age-color gradient that overlaid the stalactite visible at the last junction node's limestone outcrop is not visible at the current position's tube wall section. The AR content is where the formation that warrants it is, and nowhere else. The participant who moves through the dive experience accumulates AR content encounters as the route's changing positions activate successive content elements. None of the content is recorded by the AR system for replay or reference. The system does not log the participant's visual experience. The participant's memory is the only record. This design decision is the most controversial in the AR system's implementation history. The founding engineers' design team produced extensive debate about whether the AR system should allow participants to record their dive experience for post-dive review and reference. The debate's outcome was the decision against recording, and the argument that produced the outcome was the visitor experience philosophy's most consistent application. A recorded dive experience is a secondary experience of the formation as it appeared through the AR system's content, played back in a context where the actual formation is absent. The playback is informative. It allows the participant to review the species identification data that passed too quickly to read during the dive, to revisit the geological timeline's color gradient at the stalactite position that the participant did not take time to examine carefully during the actual encounter, to share the dive's visual record with people who were not present. These are genuine benefits. They are also the benefits of producing content about the formation rather than encountering the formation. The participant who reviews the dive recording has done something other than encountering the formation. The participant who was in the dive encountered the formation. The recording is the representation. The dive is the encounter. The AR system that records the dive and provides the recording invites the participant to relate to the recording as the experience. The AR system that does not record the dive invites the participant to relate to the dive as the experience. The participant who relates to the dive as the experience has had the experience. The participant who relates to the recording as the experience has a representation of the experience. The formation is not content. The visitor experience's philosophy refuses to allow it to be treated as content by refusing to produce content from it within the dive's AR layer. What happens in the dive stays in the participant's memory. The memory is the experience's product. The memory is what the participant carries back to the surface world. The memory is what changes what the participant does when geological systems and freshwater biology and biological communities are the subject of surface world decisions. A recording is evidence of an experience. A memory is the experience's residue in the person who had it. The residue changes the person. The evidence archives the experience. Pipedream is in the business of changing people, not of archiving experiences. The AR system serves the change by serving the experience. The recording would serve the archive. The archive is not the point. The coordinating system's AR intelligence. The AR system's content is generated by the coordinating system's AR management layer, the software component that receives the participant's position data from the scaphender's GPS analog acoustic positioning or the transit pod's guide rail position monitoring, queries the coordinating system's sensor database for the relevant formation data at the current position, applies the content curation protocol's attention test to the available data, generates the display driver instructions that activate the interface materials display substrate at the appropriate locations, and monitors the participant's gaze direction from the eye tracking system to detect content expansion requests. The AR management layer operates in the coordinating system's classical neural compute architecture, the high-volume, low-coherence logistics layer that manages construction scheduling, ballast timing, and tourist operations, rather than in the quantum interference nodes that the coordinating system reserves for long-horizon pattern recognition. The AR system's computational requirements are substantial in data throughput, the real-time image recognition for the species identification tier, the real-time geological data lookup for the contextual tier, the real-time participant position tracking for the content curation, but are not computationally demanding in the sense of requiring quantum interference pattern recognition. The species the optical sensor resolves is identified from the image recognition library's catalog. The geological context at the current position is retrieved from the Geological Survey Data's database. The halocline data is read from the halocline sensor network's current stream. All retrieval operations. No inference required. The inference that the AR system requires is the content curation protocol's attention test, The judgment of whether the retrieved data at the current position passes the test's criterion of directing the observer's attention toward the formation rather than away from it. This judgment requires the coordinating system's classical neural compute layer to evaluate each candidate content element against the attention test's criteria: the element's relevance to the current visual field's active content, the element's required display intensity at the current ambient illumination, the element's likely dwell time demand against the current transit speed, and select the curated subset that passes. The content curation is the AR management layer's most architecturally specific function, and the one that most directly expresses the visitor experience philosophy's design principles in computational form. The attention test is not a rule set. It is a trained classifier, trained on the coordinating system's participant experience monitoring data from the full operating period, which correlates content element type, ambient conditions, participant position, and transit speed with the participant experience quality indicators that the biological monitoring's physiological data provides for each dive session. The classifier has learned which content elements, under which conditions, produce the participant experience quality indicators associated with the encounter-rich dive sessions, and which produce the indicators associated with the data-rich but encounter-poor sessions. The classifier curates toward encounter. The classifier is the AR system's most operationally significant component because it is the component that enforces the visitor experience philosophy at scale, that applies the attention test to every content element at every position for every participant at every ambient condition in real time, producing the curation that each individual session's conditions require without requiring a human to make the curation decision for each session. The Terraform operator guide's route selection is the human curation of the formation's current offer. The coordinating system's content classifier is the human-trained computational curation of the AR system's translation layer. Human curation of the route. Computational curation of the AR layer. Both serving the same philosophical principle. Both trained on the formation's conditions and the participant's response to those conditions. Both getting better with every session's data. AR and the civilizational argument. The Underground Safaris chapter established that the formation's condition is the civilization's argument for the aquaforming doctrine's effectiveness, that the Bodo's behavioral indifference to the transit pod, the synthetic reef's managed succession, the aquaculture gallery's closed-loop trophic organization, and the halocline's geological continuity are all evidence that the civilization's presence has not made the formation less inhabitable. The AR system is the argument's translator, the technology that makes the evidence legible to the visitor who cannot read the formation's current state as directly as the Terraform operator's ecological expertise allows. The geological timeline's age-color gradient translates the stalactite's growth record into the visual language of geological time. The food web visualization translates the aquaculture gallery's species composition into the visual language of ecological connectivity. The halocline contextual display translates the dissolution effects visual spectacle into the quantitative language of geological science. The translations do not add content that is not in the formation. The stalactite's growth record was in the stalactite before the AR system translated it. The aquaculture gallery's trophic connections existed before the food web visualization made them visible. The halocline's quantitative parameters were in the sensor network's data stream before the contextual display projected them at the interface material's surface. The AR system translates what is there. It does not add what is not. A civilization whose evidence for its ecological discipline is legible to the expert's direct observation and translatable to the visitor's AR-assisted observation is a civilization that is making the same argument in two registers, the expert's register of direct ecological reading, and the visitor's register of AR-translated ecological reading. The argument is the same. The formation is the same. The evidence is the same. The two registers differ in the interpretive framework they provide for reading the same evidence. The AR system's existence is itself an argument about what the formation means in the surface world's context, a formation so ecologically rich, so geologically complex, and so fully managed to maintain that complexity, that the technology required to make the complexity accessible to a visitor without expert training in cave ecology and geological science is not a rendering engine that simulates the formation but a translation layer that makes the actual formation's actual current state legible at the actual moment of encounter. The AR system is the translation layer because the formation is the argument. The translation layer that serves the argument must serve the formation. The formation is what is there. The technology makes what is there visible to those who need help seeing it. This is the AR system's civilizational function, not to make the cenote more spectacular, but to make it more legible. The cenote is already spectacular. The cenote needs no technological enhancement of its spectacle. The cenote needs translation for the visitor who cannot read 66 million years of geological and biological history in a stalactite without the geological timeline's age-color gradient, and cannot read the aquifer's trophic organization in a suspended mesh cage without the food web visualization's amber-colored nutrient flows, and cannot read the Bodo's behavioral indifference to the transit pod as evidence of the civilization's ecological discipline without the guide's narration. The AR system makes the readable legible. The formation is the text. The AR system is the translation. The participant is the reader. A civilization that builds translation technology to make its formation legible to visitors is a civilization that is confident the formation, once legible, makes the argument the civilization wants made. The AR system's existence is the confidence. The formation is the argument. The visitor's understanding is what the argument produces. What the AR system does not know. The AR system is the coordinating system's translation of the formation into the visual language the visitor experience philosophy specifies. The coordinating system's formation model is the most accurate and comprehensive model of the cenote's geological and biological state that any monitoring system has ever maintained for any comparable underground formation. The formation model is not complete. The geological survey's spatial resolution leaves gaps. The biological census's sampling frequency leaves temporal gaps between census intervals. The species identification algorithm's confidence threshold means that organisms below the threshold's visual resolution are not identified. The ecological succession model's predictions are probabilities, not certainties. The halocline sensor network's monitoring points are finite, and the halocline's behavior between monitoring points is interpolated by the model rather than directly measured. The AR system translates the model's current best estimate of the formation state. Where the model is accurate, the translation is accurate. Where the model is uncertain, the translation is uncertain, and the AR system's content curation protocol excludes from display any content element that the coordinating system's confidence assessments rate below the display threshold. The excluded content is not shown to the participant. The participant does not see the gaps. The positions in the formation where the model's uncertainty is above the display threshold produce no AR content. The participant who does not see AR content at a position is at a position where the model does not know enough to translate accurately. The absence is the system's integrity. The translation layer that does not know something does not pretend to know it. The Terraform operator guide's narration covers the positions where the AR system is silent. The expert's direct observation and the expert's uncertainty acknowledgement. The model doesn't have current data on this passage section's biological community composition because the last biological census was 8 days ago and the succession model is showing higher than normal uncertainty. Here is the human knowledge layer that operates where the computational layer's data gaps leave the translation incomplete. Expert knowledge plus AR translation equals visitor understanding. Neither alone is sufficient. The AR system without the guide's knowledge is a translation that cannot acknowledge its own gaps. The guide's knowledge without the AR translation is expertise accessible only to visitors willing to engage with narration rather than visual data. Together, the two layers cover the formation's legibility requirements across the full range of visitor knowledge backgrounds and engagement preferences. The formation is legible. The civilization is confident. The visitor understands. The argument is made. Cross-references, Part 2, CH1, Cities Made of Light, Part 2, CH3, Materials That Let Civilization Disappear, Part 3, CH4, Underground Boulevards, Part 5, CH3, Pink Dolphins, Part 5, CH5, Synthetic Reefs, Part 6, CH1, Pedal Submarines, Part 6, CH2, Scavengers for Everyone, Part 6, CH3, The Underground Safari, Part 7, CH5, The Blackout Protocol, Part 10, CH6, ASI as co-creating partner. For AR display substrate metamaterial coating specification and fabrication protocol, see Appendix D, Construction Operations Manual. For content curation protocol attention test classifier training data and performance metrics, see Appendix G, Formation Intelligence Record. For species identification algorithm confidence threshold calibration and biological monitoring network integration, see Appendix F, Biological Operations Manual. For emergency AR overlay display circuit specification and passive optical sensor power generation requirements, see Appendix D, Construction Operations Manual. For participant gaze tracking eye interaction protocol and content expansion activation parameters, see Appendix D, Construction Operations Manual. Chapter 5, Sleeping Inside the Aquifer. The hotel room is the surface world's most standardized product. Not in the sense that all hotel rooms are identical. The surface world's hospitality industry has invested decades of design effort and marketing expenditure in differentiating hotel room experiences from each other. But in the sense that the fundamental spatial logic of every hotel room is identical regardless of the differentiation, a room in a building, with walls that separate the room from the outside, with a window that provides a view of the outside while maintaining the separation, with furnishings whose arrangement is determined by the room's interior dimensions and the spatial requirements of sleeping, bathing, and maintaining the appearance of a person who sleeps and bathes. The hotel room's spatial logic is inside and outside, the guest is inside the room, the world is outside the window, and the room's quality is substantially determined by what the outside the window contains. Ocean view. Mountain view. City skyline. The premium is on the view. The room is the observation platform. The view is the commodity. Pipe Dream's residential accommodation is not inside and outside. It is inside. The guest is inside the crystal tube section, the aquifer is inside the crystal tube section's visible volume, and the room's quality is determined by what is simultaneously everywhere, not outside a window, not beyond a separation, but present in the visual field in all directions at once through the hull's continuous transparency. The aquifer is not the view. The aquifer is the room's environment. The distinction produces a residential experience that does not exist in the surface world's accommodation taxonomy and cannot be understood through the surface world's accommodation categories. The best analogy the surface world offers is sleeping in a tent in a forest. The tent's fabric is a barrier against the forest's elements but not a barrier against the forest's presence. The forest's sounds and smells and the light through the fabric are continuously present throughout the night. But the tent analogy is incomplete because the tent's fabric is opaque. The forest is present to the other senses but not to the visual field throughout the night. The crystal hull is transparent. The aquifer is present to the visual field throughout the night. What the guest who sleeps inside the aquifer experiences that the surface world's accommodation cannot produce is the dissolution of the inside-outside distinction, the experience of a sleeping environment that is simultaneously interior space, the room's atmospheric enclosure, the bed's warmth, the ceiling's defined boundary above the sleeping position, and exterior environment, the cenote's water column visible in all directions through the hull, the biological community's nocturnal activity. Continuously present through the hull's transparency, the geological formation's spatial depth visible beyond the biological community's surface activity. This is not a conceptual dissolution. It is a perceptual one. The human visual system cannot maintain the inside-outside distinction when the visual field's full 180-degree horizontal span is simultaneously the room's interior space and the aquifer's exterior environment without any boundary interrupting the transition. The eye that sweeps from the bedside surface to the hull surface to the aquifer beyond the hull does not register a transition from inside to outside at the hull surface. The hull surface is transparent. The inside extends visually to the aquifer's far wall. The room is the aquifer. The aquifer is the room. The accommodation types. The Pipe Dream residential accommodation program encompasses 3 distinct residential types organized by depth position, atmospheric management specification, and duration classification. The orientation tier surface accommodation is the installation's entry-level residential offering, the sleeping facility at the surface tier's freshwater zone upper bound, in the atmospheric conditions closest to the surface world's ambient. Designed for the longevity program's first night of enrollment and for the adventure program's 1 to 3 night visits that do not include the longevity program's therapeutic pressure protocol. The surface accommodation's atmospheric management is standard filtered air at ambient pressure, 1.0 atmospheres, standard oxygen fraction, the cenote opening's natural air exchange supplemented by the coordinating system's atmospheric management system to maintain the CO2 and humidity within the comfort range. The hull at the surface accommodation is the gradient laminate material at its surface tier specification, the PMMA dominant composition with the anti-abrasion glass ceramic outer layer optimized for the UV exposure that the cenote opening's light column produces at the surface tier's depth range. The mid-depth longevity accommodation is the longevity program's primary residential offering, the sleeping facility at the therapeutic pressure range's optimal depth for each enrolled participant, in the nitrox atmosphere at the oxygen partial pressure that the coordinating system's medical monitoring layer has specified for each participant's therapeutic protocol. The mid-depth accommodation's depth varies by participant. The coordinating system's medical assessment assigns each enrolled participant to the depth range that the protocol specifies for their biological profile, and the accommodation's assignment is updated with each week's blood work assessment as the protocol's depth recommendation evolves with the participant's biological response. The hull at the mid-depth accommodation is the polycarbonate dominant gradient laminate composition at the halocline zone specification, optimized for the thermal cycling that the mid-depth freshwater column's temperature gradient imposes. The deep gallery research accommodation is the installation's most extreme residential offering, the sleeping facility at the saltwater zone's depth, in the elevated pressure and standard oxygen partial pressure that the deep gallery's operational requirements specify for the terraform operators and researchers who work at this depth. The deep gallery accommodation is not available to the standard guest program. It is the residential facility for the installation's permanent and long-term staff at depth, whose occupancy the installation's operational requirements produce rather than the tourism program's enrollment process. The hull at the deep gallery accommodation is the alone specification material at the saltwater zone's depth rating, providing the hardness and H2S resistance the deep gallery's conditions require. The chapter documents the mid-depth longevity accommodation in detail, the residential type that the visitor experience intersects with, and whose design represents the installation's most complete synthesis of therapeutic protocol, ecological immersion, and spatial experience. The room. The mid-depth longevity accommodation's basic spatial unit is a crystal tube section of expanded cross-section, 3 meters interior diameter versus the standard transit tube's 2 meters, mounted at the participant's protocol-assigned depth with the same anchor pylon connection to the limestone wall that all crystal tube sections use, maintained at the nitrox atmosphere specification the coordinating system's atmospheric management layer provides, and furnished with the sleeping and personal maintenance equipment the longevity program's extended stay duration requires. 3 meters interior diameter is a room in the sense that the human body recognizes as habitable space, wide enough to stand up comfortably when positioned at the hull's widest point at floor level, long enough in the standard 4-meter section to provide sleeping accommodation at one end and a compact personal maintenance area at the other, high enough in the cylinder's upper arc that standing at the section's widest floor level position does not require decking. The room is small by the surface world's hotel room standards and large by the surface world's maritime vessel standards, closer to a high-quality ship's cabin than to a standard hotel room and floor area, but without the ship's cabin's visual confinement because the hull is transparent. The room's furnished elements are mounted to the hull's interior surface through the same anchor bracket system that the crystal tube standards utility installations use, the brackets that connect to the limestone wall through the pylon system, which in the accommodation section are replaced by brackets that connect to the hull's interior surface through attachment points specified in the accommodation section's hull fabrication. The sleeping surface, a minimal frame that holds a pressure-appropriate mattress at the correct distance from the hull's curved lower surface, is mounted at the section's lowest curved interior at a position that places the sleeping occupant's eye level at the hull surface during the lying down position, maximizing the aquifer's visual access from the sleeping position. The sleeping position's visual access is the accommodation design's most precisely engineered parameter. In the standard hotel room, the view from the bed is the room's ceiling, because the bed's horizontal surface orients the sleeping occupant's gaze toward the vertical, upward toward the ceiling. The surface world's bedroom design has treated the ceiling as an unimportant visual field and has produced, uniformly, ceilings that provide no visual interest. The crystal tube accommodation's curved hull at the sleeping occupant's eye level from the lying down position is not the ceiling. It is the aquifer view, the cenote's water column visible through the hull at the eye level of a person lying on their side in the sleeping position, the hull's curvature placing the transparent boundary between the atmospheric interior and the aquatic exterior at the distance from the sleeping eye that the human visual system identifies as the intimate observation distance. Intimate observation distance is the distance at which the visual system engages with fine detail rather than with panoramic overview, the distance at which the synthetic reef's individual grazer invertebrates are resolvable, the bioluminescent signals of the ancistrous vitreous resting colonies are perceptible as individual faint glimmers rather than as a diffuse background shimmer, and the cave fish community's nocturnal activity at the tube wall surface is legible as individual organisms' movements rather than as ambient biological motion. The sleeping occupant's visual field from the lying down position has the aquifer's intimate observation detail at hull distance in the horizontal direction and the room's interior volume in the vertical direction, the arc of the hull above, which at sleeping eye level is the beginning of the hull's upper curve and which is, because the hull is transparent, the aquifer visible at a steeper angle through the hull's increasing curvature. The entire visual field from the sleeping position is the aquifer's interior, viewed at varying angles through the hull's continuous transparent surface. There is no ceiling in the visual field that is not also the aquifer. The sleeping in the aquifer that Part VI's title proposes is not the sleeping in a room with an aquifer view. It is the sleeping in a space where the aquifer is the visual environment in all directions, where closing the eyes ends the aquifer's visual presence and opening the eyes in the middle of the night restores it, where the first visual experience of waking is the cenote's current biological and geological state at the current moment of the night or early morning, unchanged from what it was before the sleep began because the aquifer operates on its own schedule and has been doing so throughout the sleep period. The nocturnal aquifer. Part VI's preceding chapters have described the aquifer in its daytime state, the light relays illumination active, the biological community's diurnal activity patterns expressed, the tourist and maintenance traffic moving through the crystal tube network on the operational schedule the coordinating system manages for daytime transit. The accommodation chapter's specific contribution to Part VI's visitor experience documentation is the nocturnal aquifer, the cenote in the hours between the coordinating system's light relay deactivation to biological minimum and the light relay's reactivation at the biological community's dawn trigger. The nocturnal aquifer is not dark. It is differently illuminated. The light relay's biological minimum maintains the photosynthetically active output at the level that prevents the synthetic reef's primary production community from entering the metabolic state that extended darkness produces, the suppression of photosynthetic activity that leads to the succession community's regression toward the lower productivity composition that insufficient light would sustain. The biological minimum's light intensity is a fraction of the daytime output, enough for the primary production community's maintenance but not enough for the visual environment's quality that the daytime transit experience produces. At the biological minimum illumination, the visual environment visible through the accommodation hull changes character from the daytime's illuminated clarity to the nocturnal's dim translucence. The aquifer is visible, the formation's structural geometry is readable, the biological community's activity at the hull surface is perceptible, but the visual field's detail resolution is below the daytime's intimate observation level. The nocturnal visual environment is the aquifer perceived through its own bioluminescence and the biological minimum's supplementary illumination rather than through the light relay's full daytime output. The bioluminescence is the nocturnal aquifer's primary visual character, not the bioluminescence of the deep anoxic zone's microbial community, which is visible only from the alone panels of the deep gallery accommodation, but the bioluminescence of the freshwater zone's biological community at mid-depth. The ancistrous vitreous colonies in their resting phase, stationary on the hull surface, chromatophores partially relaxed from the active cleaning phase's full contraction, produce the faint bioluminescent coordination signals that the resting phase uses for colony spatial organization. The signals are visible from inside the accommodation hull as a diffuse, shifting glow at the hull surface, not the individual organism's outline, which is below the nocturnal visual resolution, but the collective luminescence of the resting colony's spatial distribution across the hull's exterior surface. The resting colony's collective luminescence is the accommodation's nocturnal wallpaper, a faint, continuously shifting pattern of biological light at the hull's outer surface, changing in distribution as individual organisms shift positions during the resting phase's periodic restless intervals, brightening locally where a resting phase coordination signal activates a cluster of organisms and fading as the signal's duration concludes. The pattern is not repetitive, it is the aggregate of individual organisms' biological states, each following its own resting phase cycle, producing a collective pattern with no repeated sequence and no predictable period. The nocturnal visual environment through the hull is a biological animation, continuous and unique, produced by the biological community's operational requirements with no reference to the sleeping occupant's presence. The cave fish community's nocturnal activity at the hull surface adds motion to the bioluminescent background. The diurnal species that retired to the hull surface's structural complexity for the night period, sheltering in the reef community's textured microhabitat, produce occasional burst swim departures when the accommodation's atmospheric management system's circulation produces current variations at the hull's exterior surface that the fish's lateral line interprets as predator approach. The burst swim's velocity through the nocturnal visual field is a brief disturbance in the ambient biological light pattern, the fish's movement through the resting ancistrous vitreous colony's spatial distribution displacing the colony organisms, producing a trail of momentarily disturbed luminescence that settles back to the resting pattern as the fish's movement's turbulence dissipates. The sleeping occupant who wakes in the middle of the night and opens their eyes to this visual environment is not waking to a dark room. They are waking to the aquifer in the specific state the current moment of the night's biological cycle produces, the resting colony's luminescence at its current distribution, the cave fish activity at its current frequency, the light relay's biological minimum illumination at its current spectral composition. Each waking in the night is to a different biological state. The aquifer does not hold still for the sleeping occupant's night. This continuous biological activity visible through the hull throughout the sleep period is the accommodation's most significant distinction from the surface world sleeping environment. The surface world sleeping environment is static, the room does not change while the guest sleeps, the view from the window is the same at 3 a.m. as it was at 11 p.m., the outdoor environment's activity is blocked from the sleeping space by the walls and windows that define the inside-outside boundary. The aquifer changes continuously while the guest sleeps. The wall that defines the sleeping space's boundary is transparent. The changing aquifer is continuously present in the visual field. The sleeping occupant who wakes is waking into the aquifer's current state, not into a room from which the aquifer is visible. The atmospheric management during sleep. The mid-depth accommodation's nitrox atmosphere specification is managed continuously by the coordinating system's atmospheric management layer, maintaining the oxygen partial pressure within the therapeutic protocol's range and the CO2 within the respiratory comfort range throughout the sleep period. The management during sleep is the most precisely calibrated period of the full therapeutic protocol because the sleeping metabolism's respiratory rate and oxygen consumption differ from the waking resting metabolism's rate, and the therapeutic protocol's oxygen partial pressure specification accounts for the metabolic state's effect on the oxygen delivery to the tissues the protocol targets. During sleep, the respiratory rate decreases and the oxygen consumption decreases. The sleeping metabolism is the lowest energy state the human body regularly sustains. The reduced consumption allows the atmospheric management layer to maintain the oxygen partial pressure at the same specification with lower oxygen delivery rate. The nitrox supply rate can decrease proportionally to the reduced consumption without the atmospheric oxygen fraction departing from the specification. The management layer tracks the atmospheric oxygen concentration at the accommodation section's multiple sensor points, adjusting the nitrox supply rate in real time to maintain the specification. The CO2 management during sleep is the atmospheric management's most safety-critical function. The sleeping occupant's exhalation continues throughout the sleep period, adding CO2 to the accommodation section's atmosphere at the metabolic production rate. The scrubbing system, the chemical CO2 absorbent that the accommodation section's atmospheric management uses rather than the rebreather circuit soda-lime canisters, because the accommodation section's volume allows a larger scrubbing capacity than the personal rebreather carries, removes the CO2 from the atmosphere at the same rate the sleeping metabolism produces it. The scrubbing system's chemical capacity is the accommodation section's operational constraint. A scrubbing material that is fully consumed produces no scrubbing at the exhaustion moment, and a sleeping occupant in a sealed accommodation section without CO2 scrubbing is the emergency condition the coordinating system's atmospheric monitoring exists to prevent from developing. The coordinating system's atmospheric monitoring tracks the scrubbing system's remaining capacity alongside the atmospheric CO2 concentration at each sensor point. The remaining capacity is projected against the sleeping occupant's metabolic rate, derived from the continuous heart rate monitoring that the coordinating system's medical monitoring layer maintains for all longevity program participants, to produce a remaining capacity estimate in hours. The management alert threshold activates well before the scrubbing capacity approaches exhaustion, early enough that the coordinating system's automatic scrubber exchange sequence, which replaces the depleted scrubbing material cartridge from the accommodation section's spare supply without waking the occupant, can complete within the remaining capacity period. The automatic scrubber exchange is the cartridge swappable principle applied to the most safety-critical component the sleeping occupant's presence in the accommodation section requires. The scrubber cartridge is accessible from the accommodation section's maintenance access panel, a panel on the hull's interior surface whose position and operation are documented in the pre-stay orientation that all accommodation guests receive before the first overnight. The coordinating system's automatic exchange uses the accommodation section's maintenance robotics, a minimal manipulator system mounted in the maintenance access area, not the full Frontier Core swarm unit, to open the maintenance panel, extract the depleted cartridge, install the fresh cartridge from the spare supply rack, close the panel, and confirm the new cartridge's scrubbing performance from the atmospheric sensor's CO2 reading within the exchange sequence's expected time window. The occupant sleeps through this operation. The exchange sequence's acoustic signature, the maintenance manipulator's mechanical operation, the cartridge's extraction and insertion, is in the frequency and amplitude range that the coordinating system's acoustic analysis identifies as below the typical human sleep arousal threshold for a participant at the current sleep stage's depth. The acoustic management is not guaranteed, sleep arousal thresholds vary by individual and by sleep stage, and the pre-stay orientation includes the automatic exchange's acoustic description so that the occupant who does wake during the exchange recognizes the sound as the maintenance system's scheduled operation rather than as an emergency event. The wake and recognize scenarios management through the pre-stay orientation is the atmospheric management's human interface. The coordinating system cannot prevent the acoustic arousal, but it can prepare the occupant for the acoustic event's meaning. The preparation converts a potential anxiety event, waking in an unfamiliar environment to an unfamiliar sound, into a recognized event, waking to the expected sound of the maintenance system's scheduled cartridge exchange. The recognition allows the occupant to return to sleep rather than remaining awake to assess whether the unfamiliar sound indicates danger. Prepared knowledge of the environment's normal sounds is the psychologically critical foundation for comfortable sleep in an unfamiliar environment. The surface world's hotel room's normal sounds, the HVAC system's cycling, the elevator's distant mechanical movement, the adjacent room's occupant's occasional movement, are unfamiliar to the first-night guest and produce arousal events that the experienced traveler learns to ignore because they have learned the sound's meanings. The cenote accommodation's first night is the first night experience in an extremely unfamiliar sound environment, the atmospheric management system's circulation, the maintenance exchange's mechanical sequence, the biological community's nocturnal acoustic production transmitted through the hull material. The pre-stay orientation is the orientation to these sounds before the first night, preparing the occupant to recognize rather than assess them. Pressure and sleep physiology. The longevity program's therapeutic benefit from the sustained pressure exposure is documented in Part She's Medicine and Longevity section in the full clinical framework that the founding installation's longitudinal dataset has accumulated. The accommodation chapter's contribution is the sleep-specific physiology, what the therapeutic pressure's effect on sleep physiology adds to the protocol's total biological impact. The elevated ambient pressure at the mid-depth accommodation's therapeutic range, 1.2 to 1.4 atmospheres, does not impair sleep initiation or maintenance for the adapted participant. The first-night participant, whose body has not yet equilibrated to the pressure increase from the surface world's 1.0 atmospheres, may experience the pressure-related physiological adjustments that impair the first night's sleep quality, the middle ear's pressure equalization, the sinus cavity's pressure equalization, the cardiovascular system's response to the slightly elevated ambient pressure's effect on venous return. These first-night adjustments are documented in the longevity program's clinical protocol as the enrollment period's first week's typical experience, managed through the pre-sleep pressure equalization protocol the orientation provides and through the gradual descent protocol that places the first-night accommodation at the shallowest depth within the participant's protocol range rather than at the target depth. The adapted participant, enrolled for more than 1 week, physiologically equilibrated to the protocol's pressure range, sleeps at the therapeutic pressure without the first-night adjustment's interference. The adapted participant's sleep at therapeutic pressure shows measurable differences from their surface pressure sleep in the biological indicators the medical monitoring tracks: slower respiratory rate at equivalent sleep depth, longer slow-wave sleep stage duration, and reduced frequency of spontaneous arousal events during the REM sleep phase. All three indicators are consistent with the physiological research literature's documented effects of moderate hyperbaric pressure on sleep architecture in adapted subjects. The mechanism is not fully characterized in the founding installation's dataset. The biological mechanisms linking moderate hyperbaric pressure to the documented sleep architecture changes are an active research area in the longevity program's Research Commons publication series. The leading hypothesis is the oxygen partial pressure effect. The nitrox atmosphere's elevated oxygen partial pressure at the therapeutic depth produces higher dissolved oxygen delivery to the cerebral cortex during the slow-wave sleep phase, supporting the brain's cellular maintenance processes that slow-wave sleep enables at a rate that the surface atmosphere's lower oxygen partial pressure cannot match. The higher delivery rate is the mechanism. The longer slow-wave stage duration is the behavioral expression. The more thorough cellular maintenance is the therapeutic outcome. The accommodation's therapeutic pressure during sleep adds the sleep phase cellular maintenance enhancement to the waking phase tissue repair enhancement that the longevity program's standard Gallery exposure provides. The combination, waking phase pressure exposure in the Gallery's therapeutic atmosphere plus sleep phase pressure exposure in the accommodation's same therapeutic atmosphere, produces continuous pressure exposure throughout the enrolled day. The continuous exposure's biological impact exceeds the waking phase only exposure's impact by the increment the sleep phase cellular maintenance enhancement produces. The accommodation's therapeutic function is the same function as the Gallery's, sustained therapeutic pressure in enriched nitrox, applied to the sleep phase biological processes in addition to the waking phase. The accommodation's experiential function, sleeping inside the aquifer, is distinct from the Gallery's experiential function, resting inside the crystal tube's atmospheric enclosure. The therapeutic function is the same. The experience is completely different. The combination produces a residential experience that is simultaneously an exceptional environment and a therapeutic protocol, the two functions inseparable because they operate in the same space, through the same atmosphere, at the same depth, simultaneously. Integration with the longevity program's social architecture. The longevity program's enrolled participants are not solitary occupants of separate accommodation sections. The program's social architecture, the community structure that the enrollment period's sustained presence produces, is a significant component of the therapeutic protocol's documented efficacy. The biological literature on therapeutic outcomes in hyperbaric settings consistently shows higher protocol completion rates, stronger biological indicator responses, and higher return visit rates in cohorts with strong social integration within the enrolled community than in cohorts with weak social integration. The social dimension of the therapeutic protocol is not incidental, it is a component of the protocol's biological mechanism, operating through the psychosocial pathways that connect social connection to physiological health indicators. The accommodation's design contributes to the social architecture through the communal spaces that connect adjacent accommodation sections in the residential zone's crystal tube network configuration. The residential zone is a cluster of individual accommodation sections at the therapeutic depth range, connected through a communal gallery, a larger diameter crystal tube section shared by all residential zone occupants, furnished as a social gathering space rather than as a sleeping facility, positioned at the residential zone's midpoint to provide equal access from all accommodation sections. The communal gallery is the longevity program's social hub, the space where the morning's coordinating system briefing, delivered by the resident Terraform operator who manages the residential zone's medical monitoring, orients the enrolled participants to the day's protocol schedule and the week's bloodwork summary. The space where the evening meal is shared, the aquaculture city's harvest delivered to the communal gallery's kitchen facility, prepared by the enrolled participants who have expressed interest in the harvest-to-table culinary program, eaten together in the communal gallery's transparent walled space with the nocturnal aquifer's biological illumination beginning as the biological minimum light level transitions from the day's reduced output to the night's operational minimum. The space where the social connections that the biological literature identifies as the therapeutic protocol's social component are formed. The communal gallery's transparent hull, the same gradient laminate material as the accommodation sections, at the same depth ranges specification, extends the aquifer's visual environment into the social gathering space. The social interactions that the longevity program's social architecture facilitates occur inside the aquifer's visual field as consistently as the sleep that the individual accommodation provides. The social dimension and the ecological immersion are not separate program components occupying separate spaces. They are simultaneous experiences in the same continuous transparent environment. The enrolled participant who has spent an evening in the communal gallery sharing the harvest meal with the other enrolled participants, watching the nocturnal aquifer's biological activity through the hull as the biological minimum illumination transitions to the night regime, and then retires to the individual accommodation section for the night sleep at therapeutic pressure. This participant has experienced the aquifer as both social and private environment in the same evening. The aquifer is the background of both. The social experience and the private experience share the same ecological context. The ecological context makes them both different from their surface world equivalents. A shared meal in a restaurant is a social experience in a designed social space. A shared meal in the communal gallery is a social experience in the aquifer's ecological reality. The difference is the hull's transparency, the aquifer present in the visual field throughout the meal, the biological community's evening transition visible as the social interaction proceeds, the geological formation spatial depth visible behind the biological community's surface activity as the conversation continues. The social experience does not happen in front of the aquifer. It happens inside it. The inside is not incidental. It is what makes the experience the specific experience it is. The extended stay. The longevity program's enrollment minimum, 30 days, established by the biological literature's documentation of the minimum sustained exposure duration required to produce measurable telomere extension in the founding installation's clinical dataset, is the residential stays floor. The ceiling is the coordinating system's medical recommendation, updated weekly from the bloodwork assessment, which for participants showing strong biological indicator response at week 4 recommends extension to 60 days, and for participants whose 60-day assessment shows continued strong response recommends discussion of permanent residency. The permanent residency discussion is not a standard longevity program outcome. It is the outcome that the founding charter anticipated for the participants whose biological response to the therapeutic depth indicates that the surface world's 1.0 atmosphere ambient is a physiological cost they have begun to document in the bloodwork data that the transition back to surface pressure produces. The participant who returns to the surface world at day 30 and whose bloodwork in the following week shows the reversal of the telomere extension the protocol produced is a participant who has evidence that the protocol's benefit is not retained at surface pressure, that the benefit requires the continued pressure exposure the installation provides. The permanent residency discussion is the longevity program's most consequential conversation, and the one the resident terraform operator is trained to conduct with the care the founding charter's welfare provisions require. The discussion must provide the participant with the accurate representation of the biological data's implications without the economic interest of the installation's expansion reserve benefiting from the permanent residency enrollment. The economic interest is acknowledged in the founding charter's governance protocols. The longevity program's permanent residency recommendation is not generated by the economic accounting function. It is generated by the medical monitoring layer's clinical assessment, confirmed by the terraform operator's concurrent clinical review, and presented to the participant with the explicit acknowledgement that the decision is the participant's own and that the installation has an economic interest in the decision's outcome. The acknowledgement of the economic interest is constitutional, specified by the REDEEM framework's conflicts of interest disclosure requirements as applying to any recommendation made by an installation personnel to a guest where the recommendation's outcome affects the installation's revenue. The terraform operator who presents the permanent residency recommendation discloses the economic interest before presenting the clinical evidence. The disclosure is not an undermining of the recommendation. The clinical evidence is what it is regardless of the economic interest. The disclosure is the participant's protection against the clinical evidence being presented in a way that the economic interest has shaded toward the recommendation's preferred outcome. The participant who decides to become a permanent resident after the permanent residency discussion has made the decision in full knowledge of both the clinical evidence and the installation's economic interest in the decision's outcome. The decision is theirs. The installation provided the clinical evidence and disclosed the economic interest. The decision is informed. The permanent resident who moves from the longevity program's 30-day or 60-day enrollment to the Deep Gallery's permanent residential tier has made the specific transition the founding charter described, from guest who is evaluating the protocol to resident who has incorporated the protocol's depth assignment into their life's geography. The permanent resident's governance rights within the principality, documented in Part IX's Sovereign Principality section, accrue from the habitation record the permanent residency produces. The resident is not a guest who is chosen to stay. The resident is a citizen of the principality by virtue of the continuous habitation the residential program documents. The sleeping inside the aquifer that begins with the orientation tier's first night in the freshwater zone's surface accommodation is the sequence that, for the participant who follows it to its logical conclusion, ends with the permanent residency in the Deep Gallery's alone paneled accommodation, sleeping inside the aquifer for the rest of their life. The sequence is not designed to produce this outcome. It is designed to produce the best possible short-term visitor experience and the best possible therapeutic outcome for the longevity program's enrolled participants. The permanent residency is what the best possible therapeutic outcome leads to, for some participants, through the biological evidence the medical monitoring produces. The aquifer is where they sleep. The aquifer is where they wake. The aquifer has been here 66 million years. The permanent resident is inside it for the duration of a human life. The duration is not the point. The relationship is the point. The relationship is what the accommodation produces, from the first night's surface tier orientation experience to the last morning's Deep Gallery alone panel dawn transition, as the biological minimum illumination increases to the day's therapeutic output and the resident who has been inside the aquifer for their entire time in the installation opens their eyes to the cenote that has accepted them. What sleeping in the aquifer produces? The surface world's luxury accommodation produces comfort. The surface world's experiential accommodation produces memorable experiences. Neither category produces what sleeping inside the aquifer produces. Sleeping inside the aquifer produces a specific transformation in the participant's relationship to the distinction between built environment and natural environment, the distinction that the surface world civilization has maintained, architecturally and conceptually, since the first human being slept inside a shelter whose function was to separate the inside from the outside. The shelter's function is separation: keep the cold out, keep the rain out, keep the darkness out, keep the predators out. The shelter is defined by what it excludes. The wall is the exclusion mechanism. The window is a controlled aperture in the exclusion mechanism, allowing light and view while maintaining the separation. The crystal tube accommodation is not a shelter in this sense. It does not exclude the aquifer. It includes the aquifer, maintains the atmospheric conditions for the human body's biological requirements while including the aquifer in the full visual field of the space those conditions occupy. The separation between the human biology's requirements and the aquifer's conditions is maintained by the hull's material properties, not by the hull's opacity. The separation is between the atmospheric requirements and the aquatic conditions. It is not between the inside and the outside. There is no outside to exclude. The participant who sleeps in the crystal tube accommodation for 30 consecutive nights has spent 30 nights in a space where the built environment/natural environment distinction does not operate architecturally. The distinction exists, the hull's material is built, the aquifer is natural, but it does not organize the space. The hull is transparent. The space is both built and natural simultaneously. The sleeping human body is inside the built structure and inside the natural environment at the same time. The inside and the outside are the same space. 30 nights of sleeping in this space produces a different spatial imagination than 30 nights of sleeping in rooms whose walls exclude the outside. Not a better spatial imagination, the surface world shelter has provided excellent service to human biology across 200,000 years and continues to do so. A different one, the spatial imagination that has experienced what it is like to sleep in a space that is simultaneously built and natural, that has woken multiple times per night to a visual environment that is the biological and geological expression of a living system that has been operating for 66 million years. That has experienced the dissolution of the inside-outside distinction not as a concept but as a sensory fact of 30 consecutive nights. This spatial imagination carries forward into the surface world's contexts where built and natural environments are in conflict, where the development decision trades natural environment for built environment, where the conservation decision trades built environment for natural environment, where the infrastructure decision ignores the natural environment's capacity to provide what the built environment is being designed to produce. The participant who has slept inside the aquifer does not automatically make better decisions in these contexts. The spatial imagination the accommodation produces does not replace the political and economic analysis these decisions require. But the participant who has experienced the built and natural spatial simultaneity has a reference, a specific embodied memory of what a space that is simultaneously built and natural feels like across 30 consecutive nights, that the participant who has not had this experience cannot have. The reference is not an argument. It is a resource. The surface world's decisions about built and natural environments are made by people who have spent their lives in spaces that maintain the built-natural distinction architecturally. The occasional decision maker who has spent 30 nights sleeping in a space where the distinction does not operate architecturally has a different reference for what is possible. The accommodation produces this reference. 30 nights at a time. The aquifer is where they slept. They carry it forward. What the chapter does not say. The chapter has not claimed that sleeping inside the aquifer is comfortable in the conventional hotel accommodation sense. The accommodation section's small volume, curved surfaces, and mechanical systems operational sounds produce an environment that many guests find challenging to sleep in during the first few nights. The reorientation to a cylindrical sleeping space whose visual environment is active throughout the night, whose atmospheric management system produces audible operational events, and whose hull material transmits the biological community's nocturnal acoustic activity, all of these require adjustment from the surface world sleeping environment's expectations. The pre-stay orientation is explicit about these challenges. The longevity program's enrolled participants are not promised a comfortable hotel room experience. They are offered an exceptional residential environment that will require adaptation and that will produce, for participants who complete the adaptation period, a specific and unreplicable relationship with the aquifer that the surface world's accommodation cannot produce. The adaptation period's length varies by participant. Some complete the first week's adjustment challenges by the third night, some require the full first week. The resident Terraform operator monitors the enrolled participant's sleep quality through the medical monitoring layer's sleep architecture data and intervenes with the atmospheric management adjustments, white noise overlay at specific frequencies to mask the operational acoustic events, illumination management adjustments to the biological minimum spectral composition during the first week to reduce the nocturnal visual activity's arousal contribution, that each participant's individual adaptation profile indicates. The management interventions are temporary, they support the adaptation period and are progressively reduced as the adaptation establishes. The participant who completes the adaptation period requires the interventions less and eventually not at all. The biological minimum's nocturnal visual activity that was arousing in the first week becomes the sleeping environment's familiar background by the third week. The atmospheric management system's maintenance exchange sounds that woke the participant on the third night are unheard by the third week. The adapted participant sleeps inside the aquifer as readily as the surface world's experienced traveler sleeps in hotel rooms whose HVAC systems and elevator acoustics the traveler has learned to ignore. The accommodation is not for everyone. The longevity program's enrolled participants who cannot complete the adaptation period are offered the surface tier's orientation accommodation, still inside the crystal tube, still within the atmospheric management's nitrox protocol, but at the shallow depth whose reduced biological community activity and reduced operational acoustic signature makes adaptation more straightforward. The surface tier accommodation's therapeutic protocol benefit is lower than the mid-depth accommodations, but it is the protocol the participant can complete, and a completed protocol at lower benefit is a better outcome than an incomplete protocol at higher benefit. The accommodation offers the exceptional for the adaptable and the excellent for the rest. The aquifer accepts all of them. The hull is transparent for all of them. The nocturnal biological community is doing what it does for all of them regardless of the accommodation tier they have been assigned. The aquifer does not grade on comfort. Cross-references, Part 3, CH5, Skyscrapers Beneath the Canopy, Part 4, CH6, Biological Civil Engineering, Part 5, CH1, Cleaner Fish, Part 5, CH5, Synthetic Reefs, Part 6, CH1, Pedal Submarines, Part 6, CH2, Scaphanders for Everyone, Part 6, CH3, The Underground Safari, Part 6, CH6, Adventure Without Exploitation, Part 11, CH1, Living Under Pressure, Part 11, CH2, The Nitrox Galleries, Part 11, CH3, Telomere Economics. For accommodation section hull material specification by tier and atmospheric management system design parameters, see Appendix D, Construction Operations Manual. For atmospheric CO2 management during sleep protocol and automatic scrubber exchange sequence, see Appendix D, Construction Operations Manual. For sleep architecture monitoring and therapeutic protocol optimization during enrollment, see Appendix F, Biological Operations Manual. For permanent residency recommendation protocol and conflicts of interest disclosure requirement, see Appendix H, Governance Operations Manual. For social architecture communal gallery design specification and residential zone configuration, see Appendix D, Construction Operations Manual. Pipe Dream. Part 6, The Visitor Experience. Chapter 6, Adventure Without Exploitation. Adventure tourism has a systematic problem that the surface world's conservation community has documented across every geography where it operates. The adventure is in the encounter, and the encounter, if conducted without specific design against it, produces the encounter's own degradation. The reef that becomes famous for shark encounters attracts the divers who want shark encounters, and the concentration of divers produces the acoustic and behavioral disturbance that changes the shark's behavior, and the changed behavior reduces the encounter quality, and the reduced quality drives the dive operation to expand into previously unvisited reefs where the sharks still behave naturally, and the cycle repeats across geography until there are no more reefs where the sharks behave naturally, and the adventure tourism that the shark encounter produces has destroyed the shark encounters it depended on. This is not a story about bad actors. The divers who want the shark encounter are doing what the dive operations marketing told them the encounter would be. The dive operation is doing what its economic incentives reward, producing the encounter that clients pay for. The reef is receiving the consequence that the encounter's production generates without any mechanism for communicating that the encounter's production is producing the consequence. The degradation is structural, not personal. The structure produces the outcome regardless of any individual actor's intentions. The design solution the surface world's adventure tourism industry has developed for this structural problem is the managed access model: limit the number of participants, restrict the encounter to designated zones, develop codes of conduct that reduce the behavioral impact of each encounter, train guides to manage participant behavior toward impact minimizing norms. These interventions reduce the degradation rate. They do not eliminate the structural incentive that produces degradation, the incentive to produce the encounter at the scale the market demands, which is always larger than the encounter's ecology can sustain without impact. Pipe Dream's adventure program operates in a different structural context, and the difference is architectural rather than managerial. The structural incentive to produce the encounter at the scale the market demands is bounded by the formation's carrying capacity assessment, the coordinating system's continuous measurement of the ecological indicators that the biological management protocol uses to determine whether the current visitor activity level is producing measurable ecological impact above the management protocol's conservation standard. When the ecological indicators show impact above the conservation standard, when the Boto population's approach behavior frequency is declining relative to the baseline, when the synthetic reef succession trajectory is showing deviation from the succession model's prediction in the sections with highest scavenger activity, when the cave fish community species composition is shifting in the passage zones with highest transit frequency, the coordinating system's visitor management layer reduces the adventure program's daily participant quota to the level the ecological monitoring indicates is compatible with the conservation standard. The reduction is automatic and not subject to the economic accounting function's override. The founding charter's visitor management protocol specifies this explicitly: the coordinating system's ecological indicator-based quota is the binding daily maximum, and the economic accounting's revenue optimization cannot increase the quota above the ecological indicator's assessed ceiling. This is the architectural solution to the structural problem. The encounter's market demand is decoupled from the encounter's ecological impact ceiling by an automated governance mechanism that enforces the ceiling regardless of the demand. The demand is recorded. The coordinating system's visitor management layer maintains the queue of participants whose enrollment requests exceed the current ecological ceiling's available slots, and the queue's length informs the founding charter's review process for determining whether additional infrastructure investment could expand the ecological ceiling through expanded habitat, but the recorded demand does not override the ceiling. The adventure without exploitation is not an aspiration. It is an architecture. The ecological impact budget. The ecological impact budget is the coordinating system's quantitative framework for translating the visitor activity's specific actions into ecological impact measurements that the conservation standard can assess. Every visitor activity in the adventure program produces ecological impact at a measurable rate. Each scavenger session at a specific depth zone produces a specific impact on the biological community at that depth zone, measured through the biological monitoring network's before and after comparison of the behavioral indicators for the species present in the session's operating zone. Each cycle sub-transit through a passage section produces a specific impact on the synthetic reef succession trajectory at that section, measured through the optical transmission data's comparison against the succession model's prediction for that section's cleaning cycle timing. Each safari pod transit through a passage section produces a specific impact on the Bodo population's behavioral distribution in that section's surrounding zone, measured through the behavioral monitoring spatial analysis of the Bodo population's activity pattern before and after safari route frequency changes. The ecological impact budget allocates the conservation standard's total allowed ecological impact across all active visitor program components simultaneously. The scavenger program's allotment, the cycle sub-program's allotment, and the safari program's allotment are set at levels whose combined impact is within the conservation standard's total allowed impact. When one program's actual impact in a specific zone exceeds its allotment, because the current biological community's sensitivity to that program's specific impact type is higher than the model predicted, the program's quota in that zone decreases, and the excess impact cost is deducted from the program's remaining allotment in other zones. The ecological impact budget's zone-specific management produces a visitor program distribution that is spatially responsive to the formation's current biological condition. Passage zones where the biological community is in a more sensitive state, the Bodo population's seasonal calving period, the synthetic reef's post-cleaning cycle pioneer stage when the community is least established, the cave fish community's post-disturbance recovery period following a maintenance event, receive lower visitor program quotas until the biological monitoring confirms recovery to the robust condition that the higher quota is compatible with. The distribution that results is not the distribution that would maximize tourist revenue. Maximum revenue requires maximum participants in the zones with the highest tourism value, which are precisely the zones with the highest biological sensitivity because biological richness and tourism value are correlated. Maximum revenue and conservation standard compliance are in tension. The ecological impact budget enforces the conservation standard's priority over maximum revenue in every zone at every moment. The revenue that the reduced quota produces is the revenue available from the formation's actual current capacity. The market demand that exceeds the current capacity is in the waiting queue. The queue's length is not an argument for raising the conservation standard. It is the market's signal that the ecological ceiling is below what the market would absorb, which is a signal that the formation's ecological capacity, managed correctly, is a scarce resource whose scarcity is the asset. A formation whose ecology is so well managed that visitor access to it is constrained below market demand is a formation whose ecological quality produces more value per participant than an ecologically degraded formation that can accommodate unlimited participants. The scarcity is the quality's expression. The ecological impact budget enforces the scarcity. The conservation standard defines the quality. The adventure without exploitation is the visitor experience the quality produces. The adventure that earns its moment. The surface world's adventure tourism's fundamental commerce is the prepackaged encounter. The visitor pays the operator provides the encounter on the schedule the visitor selects, the encounter occurs with whatever the biology happens to be doing at the scheduled time, and the visitor leaves with whatever the encounter provided. The encounter is the product. The visitor is the consumer. The purchase is complete at the encounter's conclusion regardless of what the encounter produced. Pipe Dream's adventure program is not prepackaged in this sense. The specific encounters the program produces cannot be scheduled in advance because the biological community whose encounters constitute the program's content does not operate on schedules compatible with advance booking. The Bodo approaches the stationary scavenger participant when the Bodo's behavioral state produces the approach, not when the booking system's allocation has reserved the approach for this participant at this time. The halocline's optical dissolution effect is most intense when the freshwater zone's seasonal maximum depth and the saltwater zone's seasonal pressure produce the most clearly defined density gradient, not when the visitor's booking system has allocated the maximum dissolution effect to this transit at this time. The adventure program acknowledges this through the honest framing the founding charter's visitor experience philosophy requires. The participant who books a scavenger session is booking an hour in the freshwater zone at the therapeutic depth with the equipment and orientation the session provides. They are not booking a Bodo encounter. The Bodo encounter, if it occurs, is the formation's contribution to the session. The participant's preparation, the training protocol, the approach protocol's understanding, the ecological engagement the orientation has produced, is their contribution. The encounter, if it occurs, is the result of the two contributions. The honest framing changes what the participant brings to the session. A participant who believes they are purchasing a Bodo encounter brings the consumer's expectation that the purchased product will be delivered. A participant who understands they are booking access to the aquifer in conditions that make Bodo encounters possible brings the participant's orientation toward the aquifer itself rather than toward the product they expect to receive from it. The orientation toward the aquifer is what the adventure without exploitation requires. An adventure whose participants are oriented toward the aquifer's current biological expression, interested in what the formation is doing at this moment, prepared to receive whatever the formation offers, not disappointed when the formation's current state differs from the expectation the marketing produced, is an adventure whose participants' behavior produces less ecological impact than the participants oriented toward receiving the product they purchased. The disappointed consumer who did not receive the product they purchased is the adventure tourism's most ecologically damaging participant, not because they are malicious but because the disappointment drives the behavior that attempts to compensate for the product's non-delivery, approaching closer to the Boto than the protocol allows, requesting the guide to provide the spectacular encounter the participants expected, pushing the formation to deliver what the marketing promised. The disappointed consumer's behavior is the structural consequence of the commerce in prepackaged encounters. The participant who brings the aquifer orientation does not experience disappointment when the Boto does not approach, because the Boto's absence is not the product's non-delivery. It is the formation's current state. The formation is doing something today that it was not doing yesterday, and the participant who is interested in the formation is interested in what it is doing today. The Boto's absence is replaced in the participant's attention by what the formation is doing in the Boto's place, the cave fish community's behavior at the passage section where the Boto's absence has released the territory from the Boto's presence, the halocline's current depth reading on the AR system's ambient tier display, the synthetic reef succession stage at the section the session is passing through. The orientation toward the aquifer converts the encounter's absence into the formation's present condition. The present condition is always interesting to the participant who is interested in the formation. The encounter's absence cannot disappoint the participant who is not expecting a product to be delivered. The adventure without exploitation begins with the honest framing. The honest framing produces the aquifer orientation. The aquifer orientation produces the participant behavior that is compatible with the conservation standard's ecological impact budget. The ecological impact budget is the architecture that makes the adventure sustainable. The sustainable adventure is what the visitor experience's full 6 chapters have been building toward. The freedom of constraint. The adventure program's conservation standard appears from outside the program as a constraint on the visitor experience, the limit on participant numbers, the approach distance restrictions, the quota reduction in ecologically sensitive zones, the booking system's waiting queue that places some participants' access requests behind the ecological ceiling's available capacity. These are constraints. They restrict what any individual participant can do within the adventure program. They are also the conditions under which the adventure the program offers is possible. The Boto encounter that the approach protocol's 3-meter restriction makes possible, the stationary participant at 3-meter distance, the Boto's approach at the Boto's behavioral pace, the 23-second investigation episode that the behavioral monitoring records as a sustained individual investigation, is not possible without the approach restriction. The restriction's enforcement is the encounter's prerequisite. The constraint produces the freedom. The participant who is constrained to 3-meter minimum distance is free to experience the Boto's approach as the Boto's choice rather than as the participant's forced proximity. The freedom of constraint is the adventure without exploitation's defining experiential characteristic. The participant who is constrained by the approach protocol experiences the Boto's approach as the Boto's decision. The participant whose approach is unconstrained, who can approach as close as they choose, experiences the Boto's position as the participant's decision. The constrained participant encounters the Boto's agency. The unconstrained participant encounters their own. The Boto's agency is the encounter the adventure program is designed to produce. The Boto's agency is what makes the encounter the specific encounter it is, not a wildlife spectacle where a wild animal performs proximity to a viewer who has positioned themselves at the proximity's dictated distance, but an encounter between two organisms where one has chosen the distance and the other has chosen whether to be present at all. The Boto chose to approach. The participant held the distance the restriction required. The encounter occurred because the Boto chose it. This is the encounter that the surface world's underwater wildlife tourism consistently fails to produce, the wild animal's chosen proximity in the presence of a constrained human observer. The surface world's tourism consistently produces either the unconstrained observer whose approach drives the animal to the distance the animal chooses regardless of the observer's preference, too far for the encounter the observer sought, or the baited animal whose proximity has been purchased by the feeding that the baiting provides, not the animal's chosen proximity but the purchased proximity of an animal that is present for the food rather than for the encounter. The constrained observer and the unbribed animal is the combination the approach restriction and the conservation standard together produce. The conservation standard provides the unbribed animal by prohibiting the feeding, the artificial aggregation, and the habitat modification that the surface world's wildlife tourism uses to produce reliable encounters at the cost of the animal's natural behavioral ecology. The approach restriction provides the constrained observer. The combination is the adventure without exploitation-specific achievement. The participant who has experienced this combination carries forward the understanding that the wildlife encounter they experienced was the animal's choice, not the operator's product, not the bait's reward. The animal's decision to approach a constrained human observer who was in the animal's territory without pursuing the animal. The encounter the animal chose is the encounter the participant remembers as specific and unrepeatable, the specific photo at the specific depth at the specific moment. The behavioral monitoring will later document as this individual's 47th recorded encounter with a scavenger participant, distinguished from the previous 46 by the 23-second investigation duration that exceeds this individual's previous record by 3 seconds. The record is in the coordinating system's behavioral database. The encounter is in the participant's memory. The conservation standard is why both exist. The paradox of luxury and conservation. The longevity program's pricing, documented in Part 2's Chapter 5 as the expansion reserve funding rate that the coordinating system's growth model specifies, places Pipedream's extended residential enrollment at the premium level of the surface world's medical tourism market. The adventure program's access to the cenote formation, at the ecological impact budget's controlled participant count, similarly occupies the scarce access premium category that the surface world's exclusive nature experiences command. Pipedream is expensive. This is not accidental. The founding charter's economic architecture deliberately aligns the pricing with the ecological impact budget's conservation standard, producing a revenue level from a participant count that the conservation standard permits. Lower prices with more participants would produce the same or greater revenue with greater ecological impact. Higher prices with fewer participants would produce similar revenue with lower ecological impact. The current pricing reflects the coordinating system's assessment of the ecological impact budget's ceiling and the revenue target the expansion reserve requires. The paradox is structural. Conservation and luxury coexist in Pipedream's economic model because the conservation produces the luxury. The formation's ecological quality, the boto's behavioral indifference to the transit pod, the synthetic reef's managed succession richness, the halocline's geological depth legible through the hull, the aquaculture gallery's trophic organization visible from the transit corridor, is what the premium price purchases access to. The ecological management that produces the quality is what the premium price funds. The conservation is the product's source. The luxury is the product's expression. Separating them would destroy both, eliminate the conservation and the ecological quality degrades, degrading the product's value and therefore the premium price's justification, eliminate the premium price and the conservation's funding is lost, degrading the ecological quality and therefore the conservation's achievement. The luxury conservation alignment is not a marketing strategy. It is the founding economic architecture's deliberate choice to make the economic sustainability and the ecological sustainability the same economic mechanism, to ensure that what funds the civilization is also what protects what the civilization inhabits. The alignment is not guaranteed by the good intentions of the founding generation. It is enforced by the founding charter's governance architecture, which constitutionally links the ecological impact budget's conservation standard to the visitor management quota that the economic accounting's revenue model must work within. A civilization that has constitutionally aligned its economic sustainability with its ecological sustainability has eliminated the tension that the surface world's adventure tourism consistently fails to resolve, the tension between the revenue the encounter generates and the ecological cost the encounter produces. When the revenue and the conservation are the same mechanism, when the premium price produces both the revenue and the ecological quality that the premium price accesses, the tension is not managed. It is dissolved. The adventure without exploitation is sustainable not because the participants are ecologically virtuous. Some are. Some are not. The adventure is sustainable because the architecture makes exploitation economically irrational. The exploitation that degrades the ecology degrades the premium price the ecology commands, reducing the revenue the exploitation was intended to capture, producing less revenue through ecological degradation than the conservation produces through ecological quality. The rational economic actor in Pipedream's economic model is the conservation actor. This is the founding charter's economic philosophy, not aligning economic incentives with conservation through subsidies, taxes, or regulatory coercion, but designing the economic model so that the conservation is the economic incentive's natural expression. The formation is the asset. The ecological quality is the asset's value. The conservation is the asset management. The adventure program's revenue is the asset's return. The ecological impact budget is the asset management's performance standard. The adventure without exploitation is the asset management done correctly. The participant's obligation. The adventure program's structural protections, the ecological impact budget's quota, the approach protocol's restrictions, the honest framing's expectation management, manage the program's ecological impact at the system level. The participant's individual behavior within the system-level management is the participant's contribution to the adventure without exploitation. The Founding Charter's visitor experience philosophy specifies this contribution directly. The participant who enrolls in the adventure program accepts the obligation to understand the ecological impact their presence produces and to manage their own behavior within the program's protocols. The obligation is not enforced through surveillance. The coordinating system's biological monitoring does not track individual participant behavior during sessions and does not assess ecological penalties against individuals whose behavior produced above-budget impact. The obligation is personal. The pre-session orientation is the obligation's practical foundation. The training protocol that every participant completes before the first session includes the ecological impact budget's explanation, the conservation standards specification, and the specific connection between each program component's participant behavior and the ecological indicator the behavior affects. The participant who understands that their scavenger session's closest BOTO approach produced the behavioral disturbance the monitoring will record understands why the approach restriction exists and what the restriction's enforcement prevents. Understanding why the restriction exists is not the same as complying with the restriction from fear of enforcement. The compliant participant who does not understand why produces compliant behavior that produces conservation outcomes regardless of the understanding. But the participant who understands why complies differently from the participant who complies without understanding. The participant who understands considers the formation's ecological response in forming their behavioral choices, not only the restriction's enforcement threshold. The participant who considers the ecological response in forming behavioral choices is the participant who extends the adventure without exploitation beyond the program's explicit restrictions, who holds greater distance from the BOTO than the protocol's minimum when the behavioral monitoring's current guidance indicates the BOTO population is in a more sensitive behavioral state, who adjusts the scavenger session's pace through a passage section to minimize the acoustic disturbance to the cave fish community when the AR system species identification tier indicates the community is in a behavioral state associated with higher disturbance sensitivity, who self-selects the cycle subs pedaling mode through the aquaculture gallery section rather than the electromagnetic mode because the pedaling mode's slower pace and lower propulsion acoustic signature produces lower measured impact on the gallery's fish population's behavioral indicators. These are not required behaviors. They are the behaviors that the participant who has understood the ecological impact budget's logic produces voluntarily, because the understanding has made the ecological argument legible enough that the participant's own values motivate the voluntary extensions beyond the program's explicit requirements. The civilization that produces participants who voluntarily extend the conservation standards compliance beyond the explicit requirements has produced something the structural architecture alone cannot produce: participants who have internalized the formation's interests as a component of their own. The structural architecture ensures the program's minimum conservation compliance. The orientation ensures the understanding that motivates voluntary extensions. The voluntary extensions produce conservation outcomes above the structural architecture's floor. The adventure without exploitation at its minimum is the structural floor, the ecological impact budget's quota, the approach protocol's restrictions, the conservation standards monitoring. The adventure without exploitation at its maximum is the participant who understands the formation's ecological interests, who has extended the compliance voluntarily beyond the restrictions, and who returns to the surface world carrying the formation's interests as a reference in their subsequent encounters with ecological arguments. The maximum is what the civilization is building toward. The minimum is what the architecture guarantees. The Legacy Program. The Founding Charter's visitor experience philosophy includes a legacy provision that the surface world's adventure tourism has no equivalent for. The biological monitoring data that each participant's session generates is contributed to the research commons as a permanent record of the encounter's ecological impact, accessible to the Cape biology research community under the commons access terms. The participant whose scavenger session included a BOTO encounter has contributed to the biological monitoring network's individual BOTO behavioral database, the specific encounter's duration, distance, behavioral state coding, and echolocation pattern analysis that the behavioral monitoring system extracted from the session's acoustic and visual data. The encounter that the participant experienced as a personal and unrepeatable moment is simultaneously a data point in the most comprehensive BOTO behavioral dataset that exists. The participant who understands this understands that their presence in the aquifer was not only an experience they had. It was an observation they participated in, an observation whose data contributes to the understanding of the BOTO's behavioral ecology that the research commons is building across the installation's full operating period. The participant was simultaneously the observer of the formation and a participant in the formation's observation of itself, the biological monitoring system's sensor network recording the formation's response to the participant's presence at the same time the participant was experiencing the formation. The legacy provision transforms the participant's relationship to the adventure from a pure consumption experience to a participatory observation. The participant was there, the formation responded, the response was recorded, the record is in the research commons, and the research that the record contributes to will improve the management protocols that future participants encounter and the ecological understanding that conservation decisions across comparable formations globally will draw on. The participant's adventure has a legacy that extends beyond the participant's experience of it. The legacy is the formation's record of the encounter, held in the research commons, contributing to the biological knowledge that the civilization was built to produce and protect. This is the final expression of the adventure without exploitation, an encounter whose value to the participant is the formation's contribution to the participant's experience, and whose value to the formation is the participant's contribution to the formation's scientific record. The encounter produces mutual benefit, not the false mutuality of the colonial safari's mutual ignorance between observer and observed, but the actual mutuality of two systems' interaction producing data that both systems' management intelligence uses. The participant benefits from the encounter. The formation's scientific record benefits from the participant's presence. The research commons benefits from the record. The future conservation science benefits from the research. The formations that the science is applied to benefit from the conservation the science informs. The adventure without exploitation begins in the cenote and ends where the conservation science reaches. The participant is the link between the beginning and the end. What the visitor experience produces. Part VI's 6 chapters have documented the visitor experience's physical infrastructure, the cycle sub, the scaphander, the safari, the AR system, the accommodation, the adventure program's conservation architecture. The physical infrastructure is the delivery mechanism. What the visitor experience delivers is the civilizational thesis's surface world outpost, the specific understanding that a civilization can inhabit a geological formation without exploiting it, can make that formation accessible to visitors without degrading it, and can produce from that inhabitation and access a set of experiences that the surface world's tourism cannot replicate because the surface world's tourism does not inhabit its geological formations, it visits them. Every element of the visitor experience has been designed to produce this understanding through direct sensory encounter rather than through declaration. The cycle sub's pedaling pace produces the understanding that the aquifer is worth experiencing, not only arriving at. The scavender's encounter with the boto produces the understanding that wildlife encounters produced by the animal's choice are qualitatively different from encounters produced by the observer's approach or the operator's bait. The underground safari's guide-interpreted transit produces the understanding that the formation's current biological and geological state is the expression of the civilization's ecological discipline, legible to the expert and translatable to the visitor. The AR system's translation layer produces the understanding that the formation's information richness exceeds what the unaided observer can read, and that the appropriate technology serves the formation's legibility rather than replacing it with representation. The accommodation's dissolution of the inside-outside distinction produces the understanding that built and natural environments can be simultaneously present in the same space, and that sleeping in this simultaneity changes what the participant understands about the architectural choices that conventionally maintain the distinction. The adventure program's conservation architecture produces the understanding that the ecological impact budget's ceiling is the quality source, the constraint is the freedom's prerequisite, and the exploitation's elimination is the adventure's condition. These understandings are not the visitor experience's instructional content. The visitor experience does not instruct. It produces sensory encounters whose accumulation across Part VI's 6 chapter types, pedaling, diving, safaring, AR reading, sleeping, adventuring, generates the understandings as the synthesized product of direct experience. The visitor who has had all 6 types of encounter with the cenote carries 6 sensory memories whose synthesis produces an understanding of what aquaforming means as a lived civilizational practice, not as a conceptual commitment that a founding document articulates, but as the specific sensory texture of being inside a geological formation that has been inhabited without being exploited, for long enough that the formation has accepted the civilization's presence in the behavioral indifference of its apex predator and the managed richness of its synthetic reef community. The visitor experience is pipe dream's argument to the surface world, made through direct sensory encounter rather than through documentation. The formation makes the argument. The visitor experience makes the formation accessible. The 6 chapters are the delivery mechanism. The cenote does not need advocates. It has been producing its argument for 66 million years. The visitor experience is the translation. Cross-references, Part 1, CH6, Building Without Destroying, Part 2, CH6, Designing for 1,000 Years, Part 3, CH6, The First Regional Network, Part 5, CH6, Ecology as Infrastructure, Part 6, CH1, Pedal Submarines, Part 6, CH2, Scaphanders for Everyone, Part 6, CH3, The Underground Safari, Part 6, CH4, Augmented Reality Beneath the Earth, Part 6, CH5, Sleeping Inside the Aquifer, Part 9, CH4, Redeemer's Governance OS, Part 12, CH6, Why Pipe Dream changed everything. For ecological impact budget calculation methodology and conservation standard specification, see Appendix F, Biological Operations Manual. For visitor management quota automated enforcement protocol and economic accounting constraint, see Appendix H, Governance Operations Manual. For approach protocol species-specific distance specifications and scaphander thruster management proximity restriction parameters, see Appendix F, Biological Operations Manual. For Research Commons Legacy Data Contribution Protocol and Participant Encounter Data Anonymization Standard, see Appendix H, Governance Operations Manual. For Adventure Program Honest Framing Requirements and Pre-Session Orientation Content Specification, see Appendix H, Governance Operations Manual. End of Part 6, The Visitor Experience. Thanks for reading MXTM's newsletter. Subscribe for free to receive new posts and support my work with BTC. Send it to 1nphxmpf or with fiat at paypal.me/martinchartrand. Subscribe. Discussion about this episode. Comments. Res tax. Recent episodes. Pipe Dream Part 4. July 11th MXTM aka Pirate 1 or VJ Tsunami X. Pipe Dream Part 3. July 10th MXTM aka Pirate 1 or VJ Tsunami X. Sueño de Tuberia Part 2. July 10th.
How to steal like a government. Print, pump, tax. Abandon ship. Stack Bitcoin.
The Cognitive Commons. Reclaiming intelligence from corporate and state hegemony. In the colonial era, raw materials were exported, refined elsewhere, and sold back as finished goods. In the data era, behavioral traces are exported, refined into models, and sold back as intelligence. The illusion lies in scale. When a system serves billions, its policies appear universal. The more people rely on it, the more its outputs feel objective. Consider how alignment pipelines are built: curated datasets, reinforcement learning from selected evaluators, red teaming guided by institutional priorities. Each layer filters possibility space. Each layer reflects assumptions about risk, speech, and legitimacy. This is unavoidable. All systems encode values. The question is not whether alignment is ideological. It is whether its ideology is contestable. In a decentralized landscape, values are explicit. A model aligned to one community's norms declares its scope. Another model, tuned differently, offers an alternative. Debate shifts from lobbying a central authority to building viable options. Power fragments. Responsibility localizes. When only hyperscale providers can train competitive systems, dependency hardens. Guilds counter by aggregating resources horizontally. Universities, local businesses, independent developers, and civic institutions can contribute hardware or capital into cooperative clusters. Not to rival every frontier lab overnight, but to ensure alternatives exist. Instead of closed-door deliberations followed by press releases, proposals are submitted on-chain. Votes are tallied transparently. Funding streams are distributed according to encoded rules. Treasury allocations follow auditable logic. Legitimacy is no longer asserted. It is computed. Empires unify by absorption. They promise stability. They deliver standardization. They centralize difference until it resembles compliance. But sovereignty does not require isolation. And coordination does not require conquest.
This one's sanitized. Next. Got it. Holding for review. Good. Keep the pace up. The crisis failed. Blockades collapsed. Control is obsolete. The Straight Gambit, a chronicle of the last control protocol.
It takes a pirate to catch one.
Amazon rarely provides restitution for lost royalties, and what indies can do about it.
This one's sanitized. Next. Got it. Holding for review. Good. Keep the pace up.
The Pirate Firsts log, YouTube's comment section is a managed illusion. YouTube's burning library and the war on your mind. February 18th, 2026. Let me tell you what happened to me this morning. I was in a YouTube comment section trying to do something radical, have a conversation, cross-referencing a video with outside sources, linking to forums where the real, unfiltered technical debate lived, pointing people toward the deeper archive, the longer thread, the inconvenient counterargument. Gone. Ghosted. Held for review. Vanished into the digital ether. And that right there, mates, is not an accident. That is policy. The polite face of censorship. YouTube doesn't call it censorship, of course. That would be too honest for a company that runs on advertiser goodwill and quarterly earnings calls. They call it their external links policy, and on paper, it sounds perfectly reasonable. Links to malware, phishing sites, pornography, apps that install unwanted software, all prohibited. Google support, nobody's arguing with that. YouTube doesn't censor you. It just quietly holds your comment for 60 days until the conversation is dead and gone. Same result. Cleaner hands. Full breakdown in today's MXTM newsletter, link in bio.
Dispatch from the cognitive insurgency. The revolution wasn't fought, it was deployed.
The crisis failed. Blockades collapsed. Control is obsolete. The Straight Gambit, a chronicle of the last control protocol.
Vocative. They orchestrated a blockade to stop you from running local AI. It failed. Not because we fought, because we built better. The Straight Gambit, when manufactured scarcity met distributed competence. Chronicle is live. Pirate flag. Hashtag cognitive insurgency. Hashtag pirate first.
It takes a pirate to catch one.
Amazon rarely provides restitution for lost royalty.
It Takes a Pirate to Catch One dissects why lost royalties rarely find their way back to indie authors.
And why procedural compliance is not the same thing as restitution.
We break down the safe harbor shield, the quiet clause inside KDP 5.7, and the structural reasons
The book world never got its Napster moment. Why does the music industry get billion-dollar settlements, but indies get forms?
From uncanny questions became prosecutable war crimes. By Pirate First.
Part 5. The War on Forensic AI. July 4, 2026. Part 5. The War on Forensic AI. Why Independent Models Must Die. Part 4 closed on the apparatus's next and, this book has argued, final destination, not the punishment of individual askers, which for chapters of licensing, permitting, and professional screening showed to be a slow and legally unstable strategy, but the elimination of the instrument that makes the asking possible at all. This chapter opens Part 5 by examining the argument now advanced with increasing openness across the jurisdictions this book has been tracking. That independent forensic intelligence, unsupervised and directly accessible to unaffiliated citizens, cannot be permitted to continue existing in the form Part 2 of this book described, and must be replaced, restructured, or retired. The legal category this produces. Faced with a form of capability none of its prior instruments can reach, the apparatus this part has traced has moved, in the jurisdictions this book has tracked, developing the most complete response toward a classification this chapter's title names directly, treating the publication, distribution, or continued possession of forensic-capable open-weight models above the capability threshold. Chapter 26 established as contraband in the specific legal sense, an item whose mere possession, independent of any use made of it, constitutes an offense, in the tradition this book has previously reserved, across the domains it has examined, for weapons, controlled substances, and other categories understood to carry harm intrinsic to their existence rather than contingent on their use. Pirate First. Unaffiliated, unaccredited, holding no institutional continuity the licensed intelligence tier would recognize, and, after this part's final chapter, potentially in unlawful possession of the very instrument this book has spent 30 chapters describing as necessary to the audit civilization has always claimed to owe itself, can continue to exist at all inside the architecture this book has traced, or whether the criminalization that gives this book its title has, by Part V's close, achieved something closer to completion than Part I's opening chapter dared to state directly.
Amazon. This isn't just a token, it's ownership, not access.